check. Dylan, how goes it?
Hey.
Hey, you're sounding good.
Woohoo! That sounds good to me.
Alrighty, thank you.
All right, moving to 1-2.
Check.
That's like the dissolving. Is that like a dissolving effect, like or something? There we go. Promote as moderator. I see that. I'm gonna check what I need to actually do. Okay. That real quick. There we go. Yeah, it was default here. So if you wanted to do mature. All right, that's working, right? Back to. Good.
You too?
I'm just gonna download the presentations. Hmm? Oh, you did already download them? Ah, okay. So then we can load.
I emailed everyone yesterday. Yeah, figured it out and you got it. That's not working. Yeah, I've got two versions of Facebook. Stand there. All right. So, good morning, everyone. We are back in person, so that's exciting. And this is going to be the usual containers and checkpoint restore micro conference. There are just a few kind of bit of housekeeping here. So again, the anti-harassment policy from Plumbers, you probably should have gone through that before getting here, but you haven't. And so it's mostly for those. Well, if you're in the room and you've got a question, raise your hand. Someone will show you one of the microphones. Wait until you've actually received it and speak into it, please, not like somewhere else, because the microphone is not magic. If you are remote, you can raise your hand. Hopefully, we will notice that. Ideally, turn on your webcam. That'd be great. And you can unmute your microphone to ask a question, and we should be able to hear that in the room. Alternatively, you can also ask your questions in the Matrix chat, and I'll try and see those and then ask them in the room. There's a whiteboard here, and that's it for the slides. So the first speaker we're going to have is going to be Mathieu Desnoyers, who's going to be talking about the tracer namespace, but that's going to be in another 3 minutes if we try to stick to schedule. So sit back, relax, enjoy the show. Also just wanted to quickly thank a few people, because I didn't actually do a whole lot this year. So Christian and Mike did a lot of the organization for the microconf and for Plumbers in general. And we also had Adrian, who did review the content. That was pretty easy this year because we actually didn't have to reject anything. We pretty much just accepted the entire lineup and just scheduled it. So it was nice and easy. Thanks.
We're 1 minute ahead, but I guess we can start. All right. First topic this morning, tracer namespaces. So my name is Mathieu Desnoyers. I'm CEO at Efficios. I created the content of this talk with Michael Janson, who is with me here. So let's state the problem and discuss our goals. So we want to allow tracing of kernel and user space and for instrumentation to be available and consumed from containers. So I'll skip ahead right away to the last point. So, I mean, the easy way to see it is I'd like to do a trace that is fast, that can be used from containers. But in order to be fast, we want to use kernel buffers for tracing. And strace is one of the use case, but I want the information not to come only from system call instrumentation, but also from uprobes, from user events. So that includes user space instrumentation. So we want to allow the tenants to have the ability to observe their own user space instrumentation and kernel syscalls, that the ones that are related to their own activity. So of course you don't want to leak information across different tenants that have nothing to do with one another. So it's only things like system call tracing for the threads belonging to that tenant that you want to trace. So eventually delegated NICs as well, block IO devices might be nice to have. And that should be hierarchical. So as you have a hierarchy of containers or namespace, you'd want to have a parent namespace being able to trace everything that is happening underneath. So it's not a flat model. It's really something that should be able to be done hierarchically. Right. So one approach and one way to do it, which might not be the most efficient, but could be convenient and a good first start. So we could have filtering on a per namespace basis. So would allow the in-kernel tracers to do filtering by namespace, by tracer namespace, including children namespaces. And by the way, I mean, I'm talking about a tracer namespace as if it was a thing, but today it does not exist. And I mean, that's a bit the goal of my talk. I mean, does it make sense as a context? Well, and it's more a discussion, right? And please, if you have any questions during the presentation, please ask. So so we could do filtering. So that includes children namespaces for all those various instrumentation sources that I previously discussed. And the filtering by namespace, I mean, it's a comparison. I mean, we need to compare when an event is hit, we need to compare the current namespace with all the, sorry. So we want to in the filter, we want to accept a specific tracer namespace. So when we take that information that's associated with a ring buffer, let's say, and we compare it with when the event happened with the current namespace, then we need a comparison that takes into account the entire hierarchy. So it needs to check whether what we're looking for matches anything from the hierarchy. So yeah. So another way to see the problem, which might be more efficient. So the one problem I see with that approach is that if we have large systems with many smaller buffers in different subcontainers, I mean, when an event is hit, we'll end up with a huge linked list that we have to go, and we'll fail, match, fail. So that's tons of comparisons, and that's very likely inefficient. And each of those comparisons will have to walk up a hierarchy as well. So I mean, that's a lot of things to do. Another way to see it is seeing it as a dispatch. So when the event happens, so of course, so the event is emitted from a tracer namespace. So it may have to go, let's say we associate a ring buffer with a tracer namespace. So the event would check, okay, do I have to be traced to save a copy in my own buffer? And then it just have to go up and up and up to the root, because those are the only buffers that might be interested in seeing this event. I mean, all the buffers that are in tracer namespaces that do not belong to the upward hierarchy, we don't care. So that doing that as a dispatch like this might be a good way to do it, but that would involve somehow at the design level that we can associate the per namespace ring buffers with a namespace. I mean, those should not be different, unrelated concepts. I mean, the notion of being able to have a ring buffer associated with a tracer namespace comes into play. So then we can serialize a copy of the event records into each ring buffer that are subscribed to this event. So only the current and parent namespaces may be possibly interested in the event. So it eliminates useless iteration on all the system's ring buffers and useless filtering comparisons. And it's only possible if we attach ring buffers to the tracer namespace they belong to.
So Matthew,
yeah,
interrupt and say, this problem.
Do you have microphone? Does it work?
needs to be turned on.
Sorry, can we have microphones for the audience?
Test. Yep,
Ah,
it's working
thank
now. Okay, so this problem you have with what you're calling tracer namespaces is identical to exactly the same problem that Stefan Berger is currently having with the IMA namespaces. So
Which
whatever's-
one? Sorry.
The IMA namespace, it has a set of hierarchical rules that may or may not apply in each namespace, and it has to do all of this upward stuff. I'm not saying you're doing it wrongly, but I am saying that can we have just one solution to this? So if he works out an efficient solution, you should use it, or if you can work out an efficient solution, just make sure he uses it. The other observation is that with IMA, we eventually settled on the fact that because it works in this hierarchical way, that's basically exactly the same way as the user namespace works. So there is no real separate IMA namespace. We're just going to hang off the user namespace, and you should probably consider doing the same thing as well.
Excellent. Okay.
Okay.
Thanks.
So my suggestion basically was back in the days for the IMA namespace is to stash a pointer to the IMA namespace, for example, and struct user namespace similar for bin format mounts, but that's a separate topic. So his point being that if you could hang it off directly off of user namespace instead of introducing a new namespace type, that might be worth it.
Okay.
Sorry,
Okay.
you wanted to say something.
Yeah, I just want to say two things. So the first thing, first of all, I would love to be able to use BPF trace inside a container. That would be something that I would love to be able to do. With that being said, there are two things. The one thing is that this is a current practical problem, which is that the BPF syscall is completely blocked in
The
containers.
what? Sorry.
The BPF syscall, BPF4 is
Yep.
completely blocked inside containers, and there are many things that.
Syscall interception, we actually can use BPF in containers.
Okay, ignore him. But ignore what you just said. You can do it. Okay, but in like other containers, you can't. Like in Docker containers, or whatever, you can't use BPF. That's something which is theoretically a solvable problem if we solve the whole seccomp thing. If we do manage to solve that, there's also the secondary problem of that. Presumably, you can run BPF inside a container. Can you run BPF inside a container normally? I'm asking because basically this is the whole side channel issue with like if you can insert eBPF and then it has access to a map and yada yada.
Usually you can create BPF programs. You might sometimes be able to load them, but you cannot attach them. That would require cap BPF. And that doesn't work as far as I understand.
So I think like half years ago, I was talking about a similar topic from the BPF side. I got a strong neck from almost everyone, but this is good. And BPF side we're doing this, and for this one, there's an interesting idea like focus on the ring buffer, but I guess that will not apply, not work on BPF because BPF you don't have the dedicated ring buffer. You trigger directly from the event side.
But for BPF, what maybe could be done is whatever runtime context you have could be per container, so you don't leak information between containers or something. What I call a ring buffer could be generalized to some.
Right.
What is your execution context in
Yeah.
eBPF?
I was saying that this is, I guess so to be clear, I'm not against this. And I would love to be able to have this. The thing I'm going to say is that I suspect that the side channel issue is probably going to be the main concern with having BPF based things, because even if it was a separate context, I mean, I don't mean like you're running code in kernel space, and then that has access to whatever cache that is, and yada yada, and then
Yeah.
I mean I don't know all of that.
That's
but
probably a whole other discussion
Right, yeah,
that
yeah.
we don't have the time to take in
Right, yeah, sorry,
25
you can keep
minutes.
going.
But yeah, I mean, let's keep that in
Go
mind.
ahead, sir.
Let's keep going. So in terms of resource control, what's not unclear to me, so let's say you have this, so however it's done, right, this concept of tracer namespace, and you have a ring buffer associated with it, how do you specify the resource control? Because part of ring buffer is allocating memory. So, I mean, Cgroups are pretty good at controlling, allowing a user to delegate resources. And part of my question is, how do we tie those two together? I mean, having the ring buffer associated with the namespace and having a Cgroup to control delegation of those resources. Oh yes, this subcontainer can allocate ring buffers or not, or that much memory for ring buffers, things like that. So that's really more an open question to you guys.
I mean, yeah. I mean, my guess would be really depends on when the string buffer will be allocated, right? If it be allocated when you make the namespace, then it would then end up being associated. Okay. Currently, the way we make containers is that they're created in. You haven't even joined the Cgroup yet, I don't think, when we make the namespaces, at least in run C. And so, yeah, you would not. Yeah, and it would be associated with the wrong thing. Yeah.
Yeah, I mean, normally we kind of the default behavior we've got from almost everything is you pretty much get everything and you use C groups to restrict. Whereas in this case, you don't want to do that because the everything would be quite
Infinite ring
scary.
buffer, right?
Yeah. So that's a bit more problematic, and that's not something that I think we've got much precedent for in C groups right now. For most of that config, the precedent we've got for right now is like a bunch of random syschedules, which is not.
Or maybe
not
we could
something
allow a default. I mean,
Mm.
when you create the tracer namespace, maybe it could have a default tiny ring buffer. That
The
I mean,
problem you have is that users can create an infinite amount of user namespaces.
so then you want to reserve 0.
Pretty much.
Yeah.
So basically give you hierarchical limits. That could work. Then you would need an entry under proxys user / tracer ring buff size or whatever. It's a way to hierarchically restrict resources by user. It is, right? Yeah. Yeah, it is.
It is fixed. Okay. Where is
Question
it?
over there.
No,
This charging memory controller could be used there, but there is one related issue with these objects that are not bound to a lifetime of a process. So actually, to whom should they be charged? Whether it's the process that created them or the C group where the process was. Currently, we have been discussing this about some memory controller related objects that also exceed the lifetime of the process. So there's easier, we can just charge them to the parent memory C group. But here, if you have different hierarchy for the tracers, so we would have to somehow create an association between the tracer namespace and a particular memory C group. So it depends on, yeah, there's a problem with these eternal objects.
I mean, the thing I would actually ask is that I don't actually know about how ring buffers and tracing work. Is that something that is expandable by user space effectively? You could have like a zero-sized one that would be expanded, or is it has to be fixed from the beginning? Because
Depends on the tracer technology. I mean, I won't go into this level of detail right now. I know that the F-trace ring buffer can balloon in terms of size. LTTNG cannot, so it's fixed when it's configured. That's it. But I mean, yeah.
because if it can expand, then if it can expand, then you could charge whatever housekeeping is being done for this would have to be charged to something which is not in the C group, which is going to be a problem. But the bit where you expand it, that would be you could associate it, you could charge it with the process that triggered the expansion.
However, I mean, in the common use case, you might not care about keeping the old events. You might just throw away the old buffers and allocate new ones. And I mean, that should be good enough for most use cases, which will be to set the size when you create the container.
Right. But the issue is that if you're setting the size when you create the container, there is not a C group yet for it, is the problem. At least in run C, we create the C groups later. So and actually you have to, because you have to create the C group after you create the C group namespace. No, sorry, wrong way around.
One thing I've seen for time namespace and things like that, so they have this notion of some value for child in the parent, which is available there, so that whenever you create children, that value gets used. So maybe that could be a way to do it. So in the parent, you set that for the for child, so the kind of buffer size for child, and then you create the child.
All right, so just repeating a question that was showing up in the chat. It's they're asking what the actual requirement and use case is for this thing. Use a tracer inside one container or run tracer to trace only selected tasks inside of a container.
So my use case is to trace a container, but also to be able to create a sub-process hierarchy within a container and trace just that sub-process hierarchy. So without like changing PID namespace or things like that. So I want to be in the same namespace as the rest, but just being traced as a subgroup. That's also part of my requirement. Microphone.
Yeah, this is like, oops, sorry. This is also, I mean, you could set up a container that would allow you to do this, but like, it depends if you're talking about, this is something that you would want to be able to do in like Kubernetes spawned on AWS or something like that. In that case, you would be looking at, I mean, the default setup is that half of that stuff is blocked. Like you can't unshare a new namespace. I mean, you don't even have Capsys admin, so you could unshare a namespace even if there wasn't a seccomp filter for it. But there's also a seccomp filter to block you from doing unshare at all. And again, these are all things that I would love to have, but yeah, I don't know if you'd be able to get this stuff to work with like a regular container. Even though I'd like it.
Yeah, it depends on the container workload. For us, it wouldn't be a problem because we usually don't usually have deny list filters where we just deny specific things because we run full system containers. I mean, you know, Stefan, you know, the LXD stuff. But for these application containers, a lot of them are way more restricted. So using tracing within them will be more complicated.
Yes,
But
but I
not
mean,
impossible,
that's a
right?
policy discussion.
Yeah.
I want to discuss the mechanisms.
Yeah.
And then if we get the right mechanisms and it has enough value, people will be able to make the right policy decision to maybe enable some of this.
Yeah.
So yeah, I have 4 minutes to finish my content. Let's move on. Thank you. So there's been a RFC patch set for user event. Stephen, you have to pay attention now. So for TraceFS from Bo Belgrave, Microsoft, where he wants to, so I told him that for the user events, I wanted to see how it would fit with namespaces and containers. And in an RFC patch set, he proposed adding a notion of namespace, quote unquote, within TraceFS to kind of, and by using make there, you could create a namespace. But I kind of see that it goes against the old notion of namespaces. And I mean, I'd really like to rather have something that piggybacks either on an existing namespace or a new one that we can use with clone, ZNS on share, and maybe use Cgroup to delegate the buffer size. But what do you guys think about that?
I think so. The make dear thing I don't really like, and I don't know if we. I think we should avoid having to create a whole new namespace type just for tracing, because what we really it seems like all of the permission checking and that you want you get by hooking yourself onto the user namespace itself, because it gives you hierarchical permission checking, it gives you all the capabilities and so on. It's nicely encapsulated, and it seems like exactly what you want.
Yeah.
Having a new namespace type introduces a lot of new complexity that you need to account for. And UCount is associated with user namespace.
So just to clarify, so you could create a user namespace with exactly the same mapping as
Yeah,
the parent, right?
Right, I was gonna say, the user namespace doesn't require you to have a subset of UIDs and GIDs. You can create a user namespace and promptly write the entire host map if you want, which effectively keeps it privileged if you want to.
Yep.
There's nothing preventing you from doing that. You do need to set it up that way, but it's nothing preventing you from doing that.
Now,
It's kind of identity matrix. Yeah.
now, I think one of the reasons why we did the make DR thing was the fact that I believe we wanted certain events available when not available, invisible or something like that. Wasn't that part of the case? Because, or was it because if TraceFS gives you the events that you can enable or disable? I thought the namespace was going to be able to say, okay, these are visible events that they have. Wasn't that part of the issue? So you're not going to get all, you may not get all events. Wasn't that brought up?
Okay, so that would be an additional requirement on, okay, so being able to select
Well,
which
basically, we
events
had
would
events
be
that we didn't
visible.
want shared in a namespace. Sorry, I heard a Y over there. That's why I jumped in. I answered that. Go on, Matthew. I didn't.
Yes. So the additional requirement for the user events would be that so some specific events coming from that container would be visible and could be enabled from within that
I think that's what it was. I think maybe that's what it was. The fact that you had a user events from the one. So basically, the outside world could see all events, but each container sees only their events.
So
yes, but then, I mean, one thing you could do is to have a syskernel tracing current namespace notion. So there you see your own events, and they get given to you by the kernel. But I mean, you're not creating the namespaces through
Well,
that.
They think the way it was the fact. I think it was to simplify the notion of that. I mean, that means you have to hook in. That way, if you made it from the make DR would be done outside containers. You do that's why they said this is what's visible in the permissions. I think that was the rationale for the make dir was to have it be able to, and also I think it was another part of it was it made it easier. Here's another thing. I'm trying to come back because this is months ago that we did this conversation. I believe another issue was the fact that we really wanted the host to be easily to identify these events go to this container, these events go to this container, this events go to this container. I'm not so sure. I'm not so much familiar with the namespace
Right, so-
API for that.
So independent of that problem, which we might still solve even if we hook it to the user namespace, what's the status of this user events thing? So because last time I checked, it went in, but it will not be hooked up with eBPF.
They have a patch that is actually this is one of those things where I got pushed off because of Plumbers and everything else, not be able to review the patch set. But I've not seen Matthew. Have you looked at them, right?
I looked at the
And
patch set,
Was there any issues that you received with them going?
missing lib trace point.
What?
Because lib trace point that we want to
Right.
have in user space
Right.
to allow instrumentation of user space to go to kernel tracers and
Yes.
user space tracer. Until we have that, we have kind of really no idea whether the ABI choice are the right ones, because
Right.
they may completely have to change
Right.
or have a huge adaptation layer, and I don't want that.
And I gave my promise that because right now, like I said, I have like maybe 10-15% of my time for upstream work, and right now, number one on that is my user events is number
Yeah.
one. I'm working
So-
on that before I do anything else.
So the thing currently is that they want to make use of this user event stuff, and they would like to have it available. But currently, we face the problem that the eBPF guys categorically say we don't want this. This will never be enabled with eBPF, and for all we care, it could be out of the kernel. At the same time, the ABI isn't really clear, so we need a direction with this.
Yes.
Because otherwise, we get pushed by requirements.
Yes.
Uh,
But one of the issue there, I speak personally there, Microsoft is expecting us to provide feedback on a specific timeline without any considerations about
Oh yeah.
us not being Microsoft.
Yes. Yeah.
So
absolutely.
we should get to an agreement so that I can prioritize this work, because I do that in my spare time and I don't have much.
Yeah. Understandable.
Sure.
I think we're out of. Sorry. Sorry, I'm not emceeing.
So I have more concern with like eventually this will have like one user will generate enough noise for others. Like one example would be like the kprop. You say we get a user, you can generate a kprop, or like you give the permission to the user to generate a kprop. Technically, he can generate a kprop for like all the functions.
No, so okay, you mean hooking cape probes and then saving that information into per namespace ring buffers? Is that what
It's
you
not
mean?
about saving the information because the filter will get that. You won't get any security problem, but like the performance hit with like tracing like very hot kernel functions, because you're gonna hit that kernel function whether you're in the namespace or not.
My goal there was not to enable kprobes at all for that. I mean, that was uprobes as well as user events and system call tracing. But the syscall tracing might have some performance overhead. But
Yeah,
I think we're out of time. Yeah, we can discuss later. Thank you.
Yeah, we're going to have to wrap up and switch to the next presenter. I think this was a very good and useful discussion. So thanks a lot for that.
it's starting in 5 minutes, or is it? Ah, perfect.
Thank you. Hello, everybody. I'm Pavel Tikhomirov, and I'm software developer at Virtuoso. Previously, I was talking at LPC about mounts, but today, different idea, but still in Creo. I want to talk about old known problem, like 10 years before, in restoring process trees. Okay. No. First, I will have a brief overview what we do when we restore process tree. Next, I will walk step by step over improvement of algorithms to resolve simple cases. Then I will talk about the complex case, and in the end, about the solution I propose for this case. So here's a brief overview.
Can you use a headset or something? Because you're coming out very distorted.
Oh, okay. I will try. Just a second.
Or something, or
Just a second. Just.
just a little bit. Can you make it a little better? Just a little bit.
Is it better now?
Not
Or
really.
do I lose sound at all?
Well, I mean, we can still understand you. It's just a little.
Okay, I will just talk closer. Okay, hope it becomes better. First thing to know is that Creo knows nothing about the history of process creation. Just nothing. We only see the final state. Processes can like die, fork, clone in the middle, and we don't know the order of those operations. On exit of processes, children can reparent, and the repair of where they go is different depending on different circumstances. And there is a special resource section. This resource is special because it can only be inherited and only be created by specific process section leader. And session leaders can actually have two resources. It can have born session, which is born, and then can do set seed and get another session. That's what we need to restore in Creo, actually. Here are simple algorithms. The first case is that we only have fork and set seed for creating the process tree we want to dump. So we can restore it with this simple algorithm. We just, for each process, want to find if it needs to have born seed or not. For example, session leaders, as I already told, can have two seeds, one with which they were born and the one to which they changed their seed. And we look for each process recursively and check if it can inherit its seed from parent, and if it's not, we set born seed, and so on and so on. Then we just traverse the process tree in process tree order, parent before child, and we fork children first from born seed, then process if its session leader does set seed, and then we fork other children. Note that we don't consider complex cases of fork and clone, meaning that clone parent is not handled here. Also, pig space is not handled yet. This is the algorithm, and you can see on the picture that it is just simply works. On the left, we have one tree with sessions colored, with processes colored by their session. And on the right, we have the same tree with two color processes which need to have some born seed. For example, here we need to fork all those four processes here and only then change session for process 2 and then create here. Something like this. Next step is to add exits to the picture. meaning that now processes can exit and their children would return to the reader. That's why I also add PID namespace to the picture. So we have one PID namespace and what we previously had and exit. And now when processes exit, I use the same coloring as before. And if we conclude the born seeds for each process, process 1 would have like 3 born seed, which isn't possible. Only 1 born seed is available for each process. And only session leaders can change their session. So we need to do something here, and that's how we improve the algorithm. Here, we just need to remember that as processes now can die, we need to restore session leaders, meaning that we can't create processes with the same session if the session leader is dead. We need to add them to the picture as like helper processes and get session from them. We also set born seeds in the same manner, but except for init. You understand why, because init can have like multiple of them. And next, we just check for each branch of init, meaning each chute of init. If it can inherit session from init, it means that it's okay. We can restore it like this, session or born session. And if it can't, it means that it has session leader somewhere and it was reparented from its descendants. And we try to restore this dependency. We add helper process connected as a child to a session leader, and our process child of init is moved to children of this helper. We alter the tree in this way, and after that we can fork processes like in previous algorithm, handling born seeds and stuff, and we would get some tree which is similar to what we want but not yet ready. At the end, we kill, we wait for each process to exit, which is helper, and we get the resulting tree. All branches which receive their session are reparented to init. I believe understanding this concept would be easier on the picture on the next slide. And here I need to note that in Cgroup, we actually have this implemented except for small parts, and there are actually additional parts I don't put in this presentation because it would be too long to talk. Yeah, and here's the example. The previous tree, it is restored like this. So we add, for example, here session helper, we add helper and connect it to process which need to inherit, and after we kill all helpers, the tree becomes exactly the same as it was on previous slide. Exactly the same tree we want. So the original tree in which we had the one above, I call it the historical tree. It has all dead processes in it and shows the history, how it was created actually. So in this tree, we had different topology to this one because, yeah, our algorithm doesn't know the history of creation. It just recreates some version of it. And if we had some other dependency, I don't know which one, some dependency to inherit from process 3 to process 6, for example, on this restore algorithm, we wouldn't be able to handle it. But just probably we would have a problem in future. Okay, next step is to add nested PID namespaces to the picture. Also, this example illustrates how we can enter PID namespace and demonase process so that we bring some session from lower PID namespace to upper PID namespace. Also note that on my slides, all PIDs and seeds are from root PID namespace of container. So for this example, we would get this tree, and if we just use born seeds and look on process 6, it would have like 5 born seeds, which is not possible again. So we need to somehow improve the algorithm again, and that's how it works for nested PID namespaces. So with nested PID namespaces, we still need to create session leaders for dead session leaders, which are not in tree, but we have processes of those sessions. But we need to find proper PID namespace for them, meaning that we can have zeros on multi-level seed of some process from this seed, and we need to like traverse the tree, the PID namespace tree up to find the proper PID namespace where to create the session. And next, we just do the same as we did in previous algorithm for each init process in each PID namespace. Also, we go until next init or we like see we watch on the tree from first init and until moving to next namespace, crossing across init border, and we set born seed for this cut subtree, and we again reparent branches. But when we reparent, meaning that I need to somehow fix the tree so that everyone can get their session. And here we can have like session leader in one PID namespace, and helper connecting us with this session leader would be in our PID namespace where we belong. And that's like sometimes a bit complex already, but it's still a simple case. So we fork the tree. When we need PID namespace in it, we use clone new PID. When we need to enter PID namespace, we use set on S before forking. And after all processes are forked, we just kill all helpers and get desired tree, like this. Here it's like really simple, but it can be more complex, like this tree. There are a lot of processes in different PID namespaces with same section. This is the resulting tree for this example. And we need to create helpers really carefully. So we create helper in right PID namespace so that after it dies, we reparent where we need to. That's how it works. Here are some notes. We don't care about seeds on nested PID namespace level and care only on root level because we have nice tools to set PIDs on each level, and after we have PIDs synchronized on each level, seeds would be synchronized, section IDs would be synchronized on each level too. But here is a link to my patch which tries to fix clone tree set TID feature, because it doesn't allow us, in case we have like two PID namespaces nested in one another and they belong to different user namespaces in a container, that would be a problem because set TID doesn't work in this case. It needs to have all permissions to set all PIDs on each PID namespace level, but it doesn't have it because there are two different user namespaces. Please see a link. If I have review, it would be nice. Also need to mention that there are some different resources like process group, which are actually not only inherited, they can be just set to any other process group at any moment, but they become only inherited if we enter PID namespaces. But it's like a thing for a separate talk. Also, we don't allow external seeds in our container, as you already mentioned, that only seeds created in a container live in a container. When we enter the container, we do set seed always. Okay, next level of simple algorithm. Let's add child subrepers to the picture. It is almost complex already, but in simple variant, child subrepers are only set on after the process was forked and never disabled, like Docker shim does, for example, to catch processes. Child subrepers is a way to any process, not only inits of PID namespace, to get processes reparenting in their subtree. And the algorithm to handle it, in short, is just to handle it like pid namespace inits, almost the same, but we don't have set methodology, so we should check born seeds crossing, chilled subreaper boundary, because some sessions need to inherit through chilled subreapers. And we need to accurately handle creation of session leaders and stuff. We need to put them sometimes under some chilled subreapers properly, so that we can inherit from them, so that they are not like disconnected with us, and we wouldn't be able to modify tree the way we can inherit from them. And after killing helpers, get the desired one. So for more information, you can see Virtuoso Crew code. We have it implemented, but it's not in mainstream Crew yet, because in mainstream Crew we don't have nested pid namespaces. We did it in Virtuoso for Docker support in containers. And actually, it's a bit complex already, because when I was preparing this presentation, I found 2 issues in my code, actually. That's a funny thing. That's how subreapers die, small picture which illustrates it, because if you have a subreaper in parent, you not always reparent to it, like here. Process 11 can reparent to pid namespace, and that's good. Previously, at some time before, we had an issue that process can like change parent pid namespace, and that led to some crazy pictures with chilled subreapers. And here's what the resulting tree is, and to restore it, we just basically need the same tree as was here in history. I don't need to repeat it. And let's go to complex case already. So the complex case, but on simple example here, chilled subreapers can be not only enabled, but disabled too. So if the process enables and disables chilled subreaper in the middle of process tree creation, we can create almost arbitrary tree. In this example, process 2 is chilled subreaper and process 6 dies, 7 reparents. Here we disable chilled subreaper and kill process 3, and this reparents 2. And we get this tree on the right. Why it is complex? It is complex because we don't have certainty here. We don't know which session, which process was created first, process 2 or process 4, but we clearly know that there is some order, either that way or another way, and we need to decide. There is also another example from 10 years ago. It is in Russian, but you can clearly look on pictures, and Google Translate is good on this article. So there are like different examples of this uncertainty where we don't know in which order to create processes. And if we don't know the order, there can be again some other resource which we need to inherit between 2 and 4, and we need to like use information about all dependencies between all resources on restore, which is like very hard. With chilled subreapers, again, we can create almost any tree. So we can reparent chilled to any of its ancestors. Like it's a great power. It's very hard to predict how to restore the tree created with this power. And the clone parent flag is actually the same, because it can be like handled like a sub case of chilled subreaper reparenting. It does pretty similar thing. And before fixes 5 and 6, you can look on links. We even had like a random behavior of chilled subreapers. Thanks for them. We now at better place already. And I have this tree. You can actually create it, no problem. 1 is followed by 2, 2 is followed by 3, and again, n is followed by 1, like a circle here. and such circular dependencies are like a hell for crew. We don't know which one is first, how to decide. And if we have some new dependency in future about which we forgot or don't know, we would need to rewrite algorithm again. And now let's go to solution. What I propose to fix this problem. Kaba is the abbreviation for closest right-born ancestor, meaning that we don't want to save the historical tree, but we need to save something close to historical tree to be able to know from where processes came, from where they are reparented. And the implementation is pretty similar to what the normal process tree does. It's like the same, but except for small changes. When process is forked, its Kaba is like real parent, same as in normal process fork, but to handle clone parent case, we need to set it to current to actually know which process actually created us, from which one we inherit our resources. And also, next step is when we die, when processes die. In normal tree, we reparent to repair. In Kaba tree, not when die, but when the PID is released, when the process is released, when we waited for a process, its Kaba is changed to the children Kaba would be changed from Kaba to parents Kaba, something like this. And also we need to handle threads when the thread dies and we still have other threads, not the process dies completely. We need to move Kaba children to the thread leader. That's pretty it for the algorithm. It has some other places, but there it is like completely similar to the process tree. And we put this information into proc-PID status so that each process can see its Kaba on each PID namespace level, because again, 0 is at the end. We need to be able to find even those dependencies. I sent the patch set version 3. I have a link here. It has those colored changes already. And I also have an idea that we can enable Kaba tree only for processes like recursively for PID namespace processes, not on all processes on the whole host like I do it now, but it is like if we really want performance, probably we should do this thing. This first node is for it. And here's the picture which shows us what information Kaba tree actually gives us. This is the process tree we see, and this is the Kaba tree. It shows, okay, we need to fork process 2 first, and then process 4, and then those. I actually added the self-test, which illustrates this picture where you can just test it and see how Kaba tree behaves. I actually not yet implemented restore algorithm for Crew to use Kaba, but the general idea is here. We just follow Kaba tree on restore with small differences, like we need session leaders for sessions where session leader is dead. It is quite complex to put them into the right place in Kaba tree, but it's possible. And we need to put for each process which has a parent not equal to Kaba, we need to put helper process to this process. After this process, the helper, okay? After this process would die, children would reparent to, after helper process would die, child would reparent to proper parent. And that's it. We do the same thing in this algorithm with born seeds for all processes as it in first algorithm I've presented on first slides. And then we restore processes according to this modified Kaba tree. And then we kill helpers one by one, setting shield subreaper flags for real parent where we need this process to reparent. And that's it. That's just what we want to do in Crew after we have Kaba in mainstream. I have some notes here. Kaba is actually a good thing because it is self-restoring by design. If we restore the tree of processes by Kaba, it would have the same Kaba tree. There are actually attempts to create like clear mathematical models to restore processes, but the problem with them that in Creo we have like pretty much hard-coded order of things. We just say, okay, let's first create processes, then create files, then create something else. But in mathematical algorithms, it is important to consider all dependencies like initially and reorder all comments to create processes right from the beginning. And it would like create different order each time, and it would be very hard to debug such a thing. So okay, in Linux we can get some new resources, new dependencies between them. And yeah, it would be unclear how to define it like in clear mathematical model. But Kaba gives us an ability to know as much as we can about process creation order so that we can make this order like to put it in steel and never change it. Something like this. Also, why we don't care, why we don't take historical tree and invent some Kaba, because historical tree is affected by PID reuse. If like we have processes, if we have tree with dead processes in it, it would be hard to understand children when PID is reused and we have two processes with the same PID. Something like this. Thank you a lot. Hope it's not too much crazy. I hope to have some feedback on it. Thank you.
Okay, we've got like about 2 or 3 minutes before the next talk. I think Andre's got a question over there.
Yeah, I have a few comments about this. This is one of the major problems that we have right now in Creo. It's a big mess in our code, even without nested feed namespaces. So it's a good thing to fix. So my first question, I have to ask it because anyway, someone will ask it. Do we have other users for Kaba tree if we will merge them to the Linux kernel? I mean, it's so hard to merge something that is specific for one project.
That's a good question, because actually we can have other users. Sometimes, for example, the process can enter your, some user can enter your hardware node from like outer world via SSH and create some daemon process and just leave it there. And you, with Kaba, you can understand that this process was created by this SSH, something like this. Not sure if it's too helpful, but probably it can be useful information for like admins to know which process is reparented from where.
Okay, I mean, we need to describe this as use cases in a patch set.
Yeah, this one is in the patch set.
I think, have you considered to build this Kaba tree in user space? Because it looks simple that you can create a small daemon that will subscribe for trace events and get events about new tasks, get events about the tasks that build this Kaba tree in user space, and you will not need to add this Creo specific feature to the kernel.
All right, I'm we're out of time on this one. You can probably chat on the Matrix chat for now, because both of you should be on there, or
Yeah, sure.
organize something afterwards. Thank you very much for this talk.
Thank you.
Next up, we've got Alexa. It's going to be going over how to make ProcFS safe, considering all of the magic link craziness that's in there.
Yeah. So hi everyone. This is let's say a spiritual continuation of a talk I gave some time ago about OpenAT 2. And as you'll see, OpenAT 2 solved most of our problems, but there were some other things which actually, the original point of this talk was I was going to give some ideas about how we might fix some of the issues with ProcFS, but Christian and I were hacking on this the other day, and we actually figured out that there is a way to do this safely, but you'll see what I'm talking about in a second. So I'm very happy to take questions and things, because I have a feeling I won't make the full half an hour, because I'm not going to be doing any proposals here, but yes. So very quickly, the threat model. Now, before someone throws something at me, I want to point out I did not come up with this. So the basic issue is that certain container orchestrators that start with a K have this model that basically you can allow users who are not supposed to have privileges to configure the mount table of containers. And the net result is that we have had some very, very painful container breakout attacks, or attacks where basically you could end up with a container that doesn't have SE Linux labels or AppArmor labels applied, and so on and so on, which all boil down to the fact that when we're executing in run C, we are joining a namespace, and then we use the procfs in that namespace to then configure the container. We don't bring in a procfs because there were attacks where you could access the procfs and then you could get access to the host. So we use the container one. The problem is that if the mount table has been messed with, which should not be possible because that is not something that we allow, but again, certain container runtimes that start with a K do allow it and end with S. So the net result is that we have to figure out a way that we can at least detect that this has happened, and that we exit with an error as opposed to not setting AppArmor labels and yada yada. And yes, obviously container runtimes, and specifically our container runtime, particularly cares about this. But I mean, it's kind of a little bit strange that there is, as you'll see in a second, there was no real way, and we've now figured out a way where you can get access to, you can at least be sure that the procfs that you're operating on is the real one, and you're not being messed with. So what is special about procfs? Because OpenAT 2 should have solved this already. Because OpenAT 2 with resolve flags and all the rest of it means that you won't jump, you can make it so you won't jump into a separate file system, which wasn't possible before, but now with OpenAT 2, which has been for a couple of years, has been possible to do this. The issue is that unlike with, sorry, actually the reason you need OpenAT 2 for this, and the reason why you can't just emulate this stuff in user space is because unlike with opening, let's say you do Docker CP or you do something like that where you copy a file into a container and you want to resolve a file in the container file system, okay, if you copy to the wrong file in the container, no one cares. The problem with proc has several files that are security bits, and you need to write to the right one. And the core issue is, and this is, when we had a security vulnerability with this, I was very shocked and very frustrated, which is that if you can mess around, so we actually had in run C a protection against writing to non-procfs files for AppArmor labels and SE Linux labels, where we would check, oh, is /proc is /proc self at a current, is that a procfs file? The answer is yes. The problem is that proc self shed is a procfs file that you can write anything to, and it does literally nothing, but it is a procfs file. So if there is a way to trick you to get to a that procfs file, you end up writing nothing, and you end up running as an unconfined process, which there was an attack like that. Anyway, with OpenAT 2, we actually can solve this for non-magic links. So with non-magic links, what you would do is that you open /proc, and then you check that its file type is with f_s. You check that its file type is actually procfs, and then you check that the inode number of /proc is 1, because it's guaranteed by the ABI that the root of a procfs mount has inode number 1, and then you can then just use OpenAT 2 to resolve whatever you want to resolve, and that's all fine. If it's not a magic link, sorry, a magic link, I should explain. A magic link is something like proc self xc, or proc self root, or proc self cwd, or proc self fd, any FD number, or proc self ns, any namespace. These are things that look like symlinks and taste like symlinks, but they're not symlinks. They are magic links because they, inside the VFS, they basically will pipe you through to the underlying struct file that thing was opened, or whatever is associated with it, which means that there's no, like namespace checks. You're not really resolving it. You're just being like piped directly to the underlying file, whatever it happens to be. And that's great if you want to like recover deleted files and stuff, but not so great if you're a container runtime where proc_self_xc is a binary in the host, and then you can overwrite the binary. Anyway, so the issue with magic links is that we can't use openat2 trivially, because resolve no xdev, which is this flag that blocks crossing any mount point, including bind mounts. And the problem is that proc_self_xc or proc_self whatever, if it is a magic link, is almost certainly not going to be a file on procfs. It's going to be a file somewhere else, which means you're crossing a mount point boundary, which means resolve no xdev will block you. And obviously we can't use resolve no symlinks because that obviously blocks magic links too. So this is where the original version of the slide was going to be about, hey, here I have 5 fruity ideas for how we might fix this problem. But it turns out there is a solution. So follow me on this one. So what you can do is that, there's this thing called OpenTree, which is part of the new Mount API, which was introduced a couple of years ago. And basically what you can do is that, this all requires privileges. You need capsys admin and so on and so on, but okay, whatever, in container runtimes we are privileged. It's kind of annoying that you can't do this safely without having privileges, but whatever. You make a clone
in a user namespace.
Oh, yeah. So yeah, if you're in a user namespace, you can do it, assuming you have capsys admin in that user namespace. You OpenTree/proc, which OpenTree clone, which what that does is that it's, and we'll get to that in a second, this, as an implementation detail, creates an anonymous mount namespace, which then that thing is then bind mounted into, and then this handle you can then use as if it's a regular file descriptor to a directory. You then check, as we did last time, you check that it's the right file type, and the FS type, and that it is the right inode. And then you can open the directory of the thing you want to access. So if you want to access proc_self_xc, you open your proc_self directory or proc_pid directory the way you would normally for any other safe thing. And then what you do is then you do statx to check whether or not it's a mount root. This will then check, I forgot to mention, the bold thing. You can mount on top of symlinks. I don't know how many people know that, but that is a thing that you can do. And so the main issue here is that you can mount on top of symlinks, which is actually, it might be a bug, but they wouldn't, I wasn't allowed to remove this feature from the kernel, so we have to fix it this way. Anyway, so because you can mount on top of proc_self_xc with some other file descriptor, you have to check whether or not it is a mount root. And if it is not a mount root, then that means nothing is mounted on top of it, and then you can use it. Now, the reason why this is safe and there are no races is because OpenTree clone the mount tree you get from this cannot be modified at all, like at all. And there's an example program here. But as I said, it has, this is like very undocumented. I mean, the whole Mount API is undocumented, but this is very highly implementation defined. It just so happens it works that way behavior, where it turns out that yes, so an OpenTree clone
was planned.
Oh no. So this link here is to a patch he had, which actually fixed the other issue that we had with this. But the thing is that okay, it is. Let's not say I am not sure how guaranteed this is in order for me to depend on this. But basically, the issue is that so because this thing is an anonymous mount namespace, there is a restriction in Linux that you cannot mount. You cannot do a mount operation onto a mount namespace that you are not a member of, even if you are root. Like even if you are capsys admin on the host, UID 0, the whole shebang, you still cannot mount to it. And that means that you don't have to worry about someone. Again, we're dealing with a situation where a container process can do mount inside a container, and then we'd be able to maybe mount to proc_self fd blah blah blah. So basically, we can block. We don't have to worry about that because that's not allowed, and also mount propagation is not allowed. The risk there being that if you were to set proc/proc as ms shared, and then you would then add a mount to it after this thing, then you would be able to add the race condition. The point is, because of these two things, and possibly more things that I haven't listed, this is currently safe.
Yeah. So just to clarify, so OpenTree, what OpenTree clone does, it gives you what we would call a detached mount. So similar in the old mount API, what you could have done is you could have created a bind mount, for example. Okay, you could have created a tempfs file system and mounted it at /temp. Then you opened /temp to get a file descriptor and then unmounted it unlazily. At this time, the file system isn't anywhere visible in the file system, but you still hold an FD to it. This was usually something that we wanted for safety reasons, but obviously in the old mount API, you had to make this appear within the file system. With OpenTree clone, you can get a detached file descriptor without this mounted first, get a file descriptor, unmount then. So it gives you a detached mount. But what the kernel internally does, it takes an anonymous mount namespace, meaning a mount namespace that doesn't really exist, like you can't access it from user space, you can't see it anywhere. And the consequences of this is you can perform operations on this detached mount, and it's completely private to you. Like, for example, and this is the crucial point, if you have mount propagation set up, mounts won't propagate into the detached mount. So you can be sure that there won't be any overmounts happening while you are operating on this detached mount. And this is really the guarantee that we need when we want to have something like safe exec.
Yeah. And I mean, the other thing is that we have is that with the old mount API, you can't mount to a file script with the old one, and so you would have to. Actually, I figured out this. You can actually, if you chdir into the thing into procfs, then I think maybe it might be safe ? I'm not entirely sure, but that's a thing for libpathres to deal with in a second. But yeah, so that was basically. Here is what I would have discussed. Several other things. I mean, there are other things which I haven't put in this talk because I'm not entirely sure how useful it'll be. But one of the things is that we want to have empty path for open, so you could do a file script to reopen without going through procfs entirely, which would be nice. But the fact that we can do this bit safely means that that whole thing is a separate topic. And actually, there are semantic questions that we need to sort out with that could be like a 3-hour talk on their own. But basically, the short version is that at the moment this is safe, I believe. But I would like someone either now or later to tell me that I can depend on this, as opposed to me depending on this, and it turns out, oh no, oops, we actually disabled this thing in Linux.
What do you mean explicitly? Like, we can change this as a UAPI?
Right, you can't change the way it functions, but you can change, I don't know, you could, well, someone could decide to remove this, that it's a different mount namespace check. It could be made that this is somehow associated with the actual mount namespace the thing is in. It could be, I mean,
yeah, they could technically, but we rely on this. We rely on this in various places already in Lexi and Lexi.
But do you specifically rely on that no one can mount into it? Is that something you specifically rely on?
Sorry?
Do you specifically rely on the fact that
it's an
mount
anonymous
into blah will
namespace,
always
yeah.
fail no matter who tries?
For example, I wouldn't mind if they decide to attach an actual mount namespace on it, but what I consider UAPI, like hard said UAPI, is that you don't receive mount propagation. If suddenly we were to receive mount propagation, that basically the kernel would backdoor us.
Right. Yeah. Yeah, we definitely don't need mount propagation is, yeah. We need both to not be the case, yeah. I mean, I have faith that this would not change. It's just, I feel like I need something a little bit stronger than
You've just
faith.
gotten paranoid over the years.
I've gone very paranoid, yes. When I discovered that you can mount up with symlinks, I was checking out of my bed for things for like a month. Anyway, so yeah, so I will talk about libpathres. So yeah, libpathres is something which I introduced in 2019 at a Plumbers talk. This is the slide when I introduced it in 2019. As a quick recap, so OpenAT2, which allows you to do safe path resolution, just allows you to open files. It doesn't allow you to do anything else. And this is a good enough primitive for you to be able to do basically everything. The problem is that in order to use this properly is quite complicated. I mean, using it, even if you trust /proc, is kind of complicated. But if you don't trust /proc, then you have to do this whole open tree business in your process, and then you need to know how to correctly handle this in order to do a reopen properly. And then you also have to deal with the fact that like some syscalls don't take file descriptors. So you have to go through /proc. And actually, one of the issues, which I will talk about in a second, is that if a syscall does not take a file descriptor, the traditional way, the way that we would get around that is that you would use /proc / blah, 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 blah. The problem is that if we don't trust /proc, that doesn't work. I actually have figured out that if you chdir into the parent, and it is this open tree parent of proc, and then you do a mount to the like relative path, then there should be no way to screw with you. The problem is that libpathres is a library, so we would have to spawn a thread to do this every single time, and it would be awful. But at least for old corners, it's not a problem. Sorry.
IO-Uring.
Yes. Wait, IO-Uring does the IO-Uring have a mount op? Not yet.
I don't think yet, but it will.
We can add it. But yeah. Anyway, the point is that, yeah, so using this correctly is very, very complicated. And again, the OpenAT2 stuff was added purely because we had no way of protecting against mount point crossings at all. Because the traditional way of the traditional way of protecting against mount point crossings is that you would check, whether or not is the same device number and whether it's the same whatever. You did like the statics check of the parent and the child, and you would see whether or not they're the same device or not. And the problem is that doesn't work for bind mounts. And obviously our main issue, at least with Procofest, but also with many other things, is that, well, I mean, you can create bind mounts that are very dodgy, you can so on and so on. So OpenRT solve that problem, but the question of how we'd actually use it is a separate topic. So libpathres is a Rust library that I have been writing, which basically provides a safe VFS API, which would allow you to do these resolutions safely, and then you would also have backward compatibility support where you can run on. I mean, at this point, this made even more sense in 2019 or 2020, but it would also allow you to run older kernels where it would do the old-fashioned way of doing these checks. Obviously, there are certain checks you can't do on old kernels, like the mount point stuff, but you would be able to at least avoid crossing symlink boundaries and so on and so on. And that's basically the best thing that container runtimes and everyone else and systemd and whatever else was doing before OpenAT 2. So at least you would get that for free, effectively, for old kernels. Yeah, so at the moment, what is going on with this? So with libpathres, the safe wrappers for Procofest stuff is something that I wanted to add. And now that we have a way to get safe wrappers this way, which hopefully will not be broken at some point, you can basically, we would have in the library, you would have a cache to Procofest handle that would be opened and open. Again, this requires privileges. So for unprivileged users, you would not be able to do any of this. You would have to just trust the Procofest's thing. But I guess most of the times we need to be sure that Procofest is what we want. In most cases, we're running privileged because in most cases, that's what matters. And ultimately, you only need the open tree stuff for magic links. For regular files, you can just use OpenAT 2. So it is just for magic links that we have to deal with this problem. So it's not that bad. But basically, you would have like this cached FD, which you probably could get a hold of if you wanted to do your own stuff on it. And then you would have like proc self get or something, XC, which would then give you a handle to proc self XC after checking that it actually is the real thing. And then you can then do whatever you like with that, like exec it effectively. So because in run C, we do exec the proc self XC several times, and actually LXC does now because because of the security patch we added for the other CV. Anyway, so that's that. There are some other issues like having a sane C API, which is so there is an issue, which is that we will need to run this from Go. We'll need to use this from Go. And Go programmers are used to the fact that you can close file handles more than once and nothing happens. And so in Go, the way that they do this is they have this like atomic bit magic stuff where they basically are implementing a mutex, but it's meant to be faster. And this is done in order for you to be able to do this close thing. And after the first close is all no up. The thing is that there's no way to re-implement this in Go nicely. You have to basically copy paste the code from the standard library and then modify it to not use the internal runtime mutexes or runtime semaphores that the thing has internally and yada yada. And so on, I did that. But basically the issue is that all the live list checks and all the rest of it, whether or not you have to freeze stuff, I wanted to try to make it as footgun proof as possible. But as far as I can tell, once you cross like 3 language barriers for one call, it's basically impossible to do that nicely. So at this point, I'm just wondering whether I should just make everything return an FD, and then people can either footgun themselves or not. I don't know what people's opinions on that are. I mean, at the moment, the way it works is that you get back a number, which is a pointer, but it is not actually dereferenced because in order to make sure that you don't double free, we have a global hash map. This is all going to be, I apologize in advance, which basically the pointer is actually used as a key in this hash map so that if you double free, nothing bad happens. Now, why did I do it this way? Basically, the issue was that, in Go, we wanted to make sure that this thing was safe in Go. And if I have to make it safe in Go, I might as well make it safe everywhere. I later discovered that actually I have to do it in Go twice, but that's a different topic. Basically, but if we just returned file descriptors, then there's no liveliness problems of having to allocate something and then leak it to the C code, which then has to pick up and yada yada. If anyone has an opinion about that, I would love to hear it. If just FDs are fine and everyone will survive, I don't know, because the issue is that for the root file script and stuff like that, you would have to make sure you never use anything other than the libpathres calls for it, because otherwise you would just be doing an unsafe operation. But by hiding it behind a pointer, which is not actually a pointer, then you can't. You have to. I mean, you can leak it obviously, but you would be stopped from like having a brain fart and then you're like, oh, I got this file descriptor. Let me open this thing or let me mount this thing.
So the goal of libpathres, as far as I understood, is like For example, a lot of the low-level user space programs that write or that exist that do manual symlink chasing and path resolution, right?
Yeah.
And it's pretty difficult to get this right. So this would all be encapsulated, or is all encapsulated.
It is, sorry, yeah, it's
With path
it supports all the kernels, yeah. So like basically emulates, it does that symlink chasing and all the rest of that in all the kernels. Yeah, so that's all done. The question is whether or not like actually using it, should I just give you a file descriptor back that is like, oh, this is the thing that you want, or should I do this whole awful thing? I did not anticipate how painful it would be to write Go APIs. That
I feel just from ease of programming, but this is really just my.
No one cares.
I would like a file descriptor.
Okay. Even though if you actually used it, you would break things. I mean, you probably wouldn't, but some people would. Okay. Yeah. Oh, whatever. Fine. I mean, whatever. It's a C library, so footguns are actually welcomed. Yeah, and then there's the mount API stuff. So basically, at the moment, libpathrs could actually be used. So there is a program I wrote called Umochi, which is a container image tool, and it internally has to do all this symlink stuff. And but it doesn't do anything too complicated. It's not a container runtime. It is just purely like not to denigrate my own work too much, it is basically a glorified tar. And so we do have to do a lot of operations on things and so on and so on. And so this will be the obvious first program to port. And libpathrs currently is at a point where you could port it, pretty much. But there are stuff for runc and for LXC and everyone else. The main one is the mount API. I'm not really sure what to do here because internally, we would use the new mount API for anything because, again, the issue is that the old mount API, you can't give it a file descriptor, so you have to go through proc. And the CHDIR trick aside, which I would have to think about how safe that actually is. I mean, I guess if you CHDIR into the open tree thing, then it would be safe because who's going to change anything from underneath you, right? Yeah. I guess that would be safe. It's awful, but it would be safe. Anyway, so yeah, but we would use that as a fallback. But the point is that I was wondering, should I try to have like a mount API abstraction that everyone can use, or should I just have the mount syscall, like libpathrs underscore mount, that takes the mount syscall arguments, and internally it fucks with everything?
I feel like I'm not that familiar with how many, probably other people are, with how many libraries actually exist that, for example, just do the symlink chasing for you and then safely opening the final file descriptor. I think even if you just put out a version of libpathrs that implements these basic semantics that people can link against, that would already be quite a win in my opinion. My point being, instead of waiting until you've duplicated most of the VFS API and then releasing something.
I want to avoid doing that. That is not my intention. The problem is that so the issue is that if we just have the chasing thing, then that is basically lib openat2 is what that becomes, because at that point you still have to deal with the procfs crap, and then you still have to deal with the this thing where like mount. Like if you mount, you have to know that you have to open tree, and then you have to CHDR into an open tree, and then do a mount of like mount 1, 2. like that's what you have to do basically. And yeah, I mean like that I think should work. But and then we would have to and then if you have and then overlay FS, we have to rewrite the.
I would just like to start relying on this. To be honest, that's
okay.
The thing. I want some of the code that we have that does the symlink chasing stuff, which I have no idea if this is perfectly fine what we do. I hope it is. It has held up for quite a few years, but ideally, if we could just like conditionally compile this code and then use this, would be way better.
So just first version.
I mean,
have
there is the issue will be, you expose a C API, right?
Yeah.
Yeah. Okay. The problem always is building Rust and C together.
Right, but it would be. I mean, like this would be packaged by distributions.
And it would indeed be conditional on our side because I suspect we still have some weird architectures where Rust is not much of a thing yet. I mean, mostly because like for LXD that'd be fine. For libLXC, we still got people running it on like some very weird old flavors of MIPS and shit, which is probably not ideal. So I don't think we would be able to just mandate its use, but we could make it conditional and use it if it's available.
But do you think even the Fiverr versions are still used on crappy? Sorry, not crappy. On very strange architectures. IA64.
Well, IA64, I hope not, because there should only be like a dozen machines left on this planet at this point, so probably not. Like, but I also don't think like we care about like M68K or that kind of crap, but we probably do care about like whatever weird version of Mapes is running on like an old Linksys router, because OpenWRT is shipping currently by Lexi.
It just bothers me that it seems user space is duplicating all of the symlink chasing stuff, which is like a giant.
Yeah, no, I agree. That I want that to not be the case anymore. To be honest, I think the issue is actually that a lot of user space does not deal with this because they are not aware that it is a problem or whatever. And so like OpenR2 is meant to solve this, but oops. Yeah, but the issue is that so yeah, I don't want to reimplement the entire VFS API. The key thing is that any syscall that does not have that takes a file descriptor is user space. The library user can just use it the way they would normally use it. Any syscall that takes a path and there is no other way of getting around it, if I give it to them, it's a foot gun, because if they first of all, if they would know how to use it for certain things, I mean, I guess they would be relatively clever. So they would know that they can do it through proc. But the thing is, if you do it through /proc, then it's not safe, at least in our particular use case. And it's a case of like, well, if we already have a library that is going to have to do this procfs stuff, we might as well have it so that everything is just safe, and we don't have to worry about it. But yeah, I mean, again, I know that in LXC, you guys don't have to deal with this problem because you have a cached version of the proc thing that you know is safe. Yada yada. It would be lovely if we had that. We don't have that. But yeah. Anyway, but yeah. I mean, look. If the end of this conversation is that I'm going to re-implement this entire thing in C,
no, I don't think there is a reason for that.
I mean, I re-implemented it once. It was originally in Go, so I mean, third time's the charm, right? Yeah.
I think Rust was a pretty good choice for this.
But anyway, so yeah, I think yeah, my thoughts on this have changed a little bit in the past, like let's say a couple months, where I now think that. I'd never want to re-implement the whole thing, but I think that if we just give file descriptors, especially to C, if we just give file descriptors and we have a handful of operations, yeah. But I think that we would need the mount stuff. I think we would need mount, and I think we need rename, and we need
a way to unmount by file descriptor probably.
But you can do the CHDR thing.
Oh, that's gonna be difficult. No, we don't that. We need umount at.
No, sorry. We need umount at. Definitely need umount at. But oh right, yeah. You don't want me to spawn a thread, right? Okay.
No, I'm thinking.
If you spawn a thread, because so the CHDR thing is that if you spawn a thread and then you change its directory into let's say you have a handle to which you know is that mount point, which is FD5. You CHDR into procself FD, and then you umount brackets quotes 5.
Yeah.
In OpenTree.
I know.
Yeah.
That's what you do right now.
That is what libpathers will do.
Yes, exactly.
Yes, well, that's what we will have to do. But I agree, we need a umount at. I mean, this is kind of ridiculous. Yeah, that's basically it. I mean, has any questions or throw anything at me?
A clarification for my benefit, because I didn't quite understand on the problem statement. The whole song and dance with the open tree, we need to do that anytime we have a mount being done from outside into a namespace, or only when the container manager or namespace manager is itself using proc something to avoid the problem that we were talking about?
The second one. So in run C, when you join it, because joining a container is not atomic, we join the container and then we have to do stuff in /proc. In particular, there are things which are completely impossible to do from a separate process, such as it is impossible to set someone else's app armor label, and so you have to be the process itself to set the app armor label, which means that the process which is like, I don't know, the zygote or whatever you would call it, the process that will eventually become the init in the container has to set its own app armor label. And at that point, we are currently doing this through the proc in the container. We used to have a proc handle from the host, but this was used to attack the host, because if you have a handle to /procfs from the host, and the container gets access to it, you can just go straight to the root file system of the host. Now, this is in theory fixed through setting as undumpable and yada yada, but and a bunch of other fixes. But I have I have concerns that I don't even want to have anything from the host in the container, even if theoretically it's safe. I just don't like the idea.
For example, we were joking about this yesterday, but with the iuring clone and exec command, currently when we attach or fork a new process into a container, we have to recreate the world, double fork to make sure that we are the correct child, the correct parent, have the correct parent in the container that we're executing in, and that there's so much stuff that can go wrong in between. Including the proc stuff, because we can't rely on any information that is inside, that is from inside of the container. The proc inside of the container must be untrusted. I know systemd has a different model because you talk to systemd inside of the container, but for most container runtimes, the model is the workload that is running can't be trusted. So we're not touching proc, we're not touching sys. So we always, for Lexi, we always rely on the proc of the container manager, which hangs around for us, stashes when it boots up. We have a separate handle. We basically have like a detached mount that we created when we started up the container. So that's what we operate on if we have to, but we don't touch the proc of the payload. And basically what I'm saying, if you would have something like fork into container, which would require that we have a container concept in the kernel, that would be way nicer, would be way easier. It would, it would make this all go away, because we also have to recreate Cgroups. It's made a bit easier because we have clone into Cgroup now.
Yeah, and the thing is that we have what was I say? Yeah, I agree.
I mean, and it's not helping that the the LSM API is like a random obscure file in proc, because like for Cgroups we do have the clone into Cgroup, or we can effectively pass what a Cgroup FD or something. But there's no real equivalent for the LSMs. Like we can't be like clone and that's the LSM configured, like please. Would be convenient if you could like pass in seccomp and Apamo, Linux, all that stuff through a clone, but that's a bit more obscure.
There is one thing that we do in systemd, which doesn't go to the PID1 inside, which is we allow doing bind mounts on a live system service that uses user namespaces and mount namespaces. And I need to check. We might use changing there in the namespace and then do proc self fd something. Is that something I should check and be worried about?
If you're joining a container, if you're joining namespace that is a container, okay. So the thing is, it depends entirely on the threat model. If the threat model for systemd and spawn is that like workloads in the container will not have capsys admin and we can trust PID1, then I would like for there to be more checks done, but I suspect that there isn't an attack you can do, assuming that the threat model for systemd and spawn is basically that this thing when I said at the start, that like that you're not Kubernetes. I mean, sorry, container runtime starts with a K. If you're not Kubernetes and you don't have this thing where you allow unprivileged users to specify just random mounts and stuff like that, if that is not possible, then you, in theory, wouldn't have to worry about this. Even though I would say it's probably a good idea to do something.
It's not just nspawn, it's also for system services. We run those in namespaces and allow bind mounts inside of those with user and mount namespaces. So it's not just nspawn.
So we do this differently. We have like a shared mount point. I always call it a tunnel between namespaces. And Leonard stole this from us basically. I stole it, but we're friends, so it's fine. I mean, but yeah, and then they propagate into the mount point, and then you move it, and then you unmount
yes.
On the host. Yeah.
But there might be some proc self FD to get the mounts when we're inside. So that's what I was worried about.
I've talked about this. I think you have a very different model in nspawn because you always assume that systemd is also running
in
inside
nspawn, yes,
the workload. Right? For example, where we go through all of the dance, forking into the container and so on, then execing a shell, then doing FD redirection to be able to type on the TTL and so on. They just talk to systemd inside of the container workload and say, basically give me a shell.
Right. Okay. Yeah.
But again, that's for nspawn, not for system.
So, by the way, we're slightly over. We're at 11:34. The next talk is at 11:45. It is break now, so that's why I didn't cut everyone off immediately. But it is break time. We're starting back in about 10 minutes. So feel free to keep having the discussion. It's fine. But break.
I'll come down.
All right, we're going to be starting back up. Can someone maybe close the door over there? That'd be great. Thank you. Okay, and next up we've got a talk on Cgroup R-stats. That's you.
Okay, thank you.
Thank you.
So, yeah, welcome to my talk. I am Michal Koutný. I work at SUSE, and I work on various stuff related to Cgroups. And now I would like to delve into into the recursive statistics framework. So at the beginning, I will try to explain to you who are not familiar with that, so that you get the idea, and you can join the discussions later. By the way, the original idea of RStats, it's not mine original. It's the credits goes to other people. Just to be clear. Then I will present some theory I had about the behavior of RStat in certain situations, which I try to verify with some experiment. So I will describe that. And the last part, which should be also a discussion part, I would like to initiate some possible ideas. How can this be improved? So very short description of where you can encounter the RStat framework is basically if you read from any of the .stat files in the Cgroup directory. So some of the fields are generated from data received from the RStat. Yes. So in general, there are two sides of this framework for the readers and for the writers. The readers, I mentioned them, they are visible, for example, from the user space via the files. The writers are typically inside the kernel. The writers, I will call them updaters. The readers, I will call them flushers. We will see soon why this terminology. So the writers, when they have some update for the data related to a Cgroup, so here in the picture, we can see what actually gets modified. There are two Cgroups here. The circles, the circles denote two Cgroups. At the top is the root Cgroup, and in the middle is a Cgroup that initiates the update. And we have to mark the update happens on any Cgroup that's on the path from this particular selected Cgroup to the root. But we can see that it does not concern the subtree of the updated Cgroup, for example. So yeah, we basically the work somehow is proportional to the depth of the updated Cgroup. Now, for the readers come or the read request comes from a certain Cgroup in the middle of the tree here. We see that its subtree is denoted with the dashed triangle. And yeah, we assume that there were already some updates happening before. So there are these paths leading from the various updaters under the subtree. And we have to fetch the data from these updated Cgroups and aggregate them up to the tree to the requester. And yeah, we can see here that actually we don't have to, it does not span the whole subtree. It's just the updated path. And here the amount, the amount of work that potentially that's potentially necessary to do is proportional to the subtree size, because everything can be updated in the worst case. And also, what's relevant here, it's related also to the number of controllers, because every controller can have some work with the aggregation. Yes, here is slightly the green structures I had in the previous pictures are realized in a so-called update tree, and yeah, it forms the structure of the tree, but it's independent from the Cgroup tree. Here is the quick scheme, and on the update we extend this tree, and on the flush we basically dismantle the whole tree. And what I wanted to point here in this slide is name of the structure. It's called Cgroup Airstat CPU, which I was not explicit before on the purpose, because everything what I mentioned happens in per CPU replicas. So the updaters work ideally with just their CPU data, and only when we do the flush. So the flush happens actually over all the CPUs multiple times, so that we aggregate the global state of the statistics. Okay, so this is basically what I said. Updates are per CPU. When we are flushing, so we are just concerned with the subtree of the C group that we are reading the data from, and even if there are some passive C groups with no updates, so we easily skip them because we work with just the update subtree. Here's an overview of the common updaters or the writers that currently exist in the kernel. So one of them is that was the first use of this framework was for the CPU time tracking that's used directly in the Cgroup core. Then it's also used for the tracking of the transfer data via the I/O controller, and the memory controller uses it as well for its various counters. It's divided into state counters, event counters, and other statistics. And also recently, it's now possible to initiate the update by calling the function, the existing functions in the Cgroup code via BPF kfunc framework. Then the readers. Here I put them into some categories. Initially, I was talking about the user space available files, but there are also some internal consumers of the data. Namely, it's used by the memory management code first when on the default path, and also the write back part when it bases the calculations on, when it needs the data. So it needs the memcg data for proper calculations of distribution of limits, or for the digital thing. But here I try to somehow put it into the two categories, that we have some imprecise readers that are happy with imprecise result, and readers that require precise result. But this is just my division. It's nothing conventional. So I put the user space readers into the imprecise category together also with the working set refold calculations that currently use some kind of asynchronous flushing. That I will talk about it later. So that it means that they have slightly outdated data, but it seems that it's sufficient. And the precise readers they are used in the reclaim code, the write-back code, and also currently the BPF support comes also for the readers. One interesting point is that when we remove Cgroup, we have to flush its data as well, so that we keep the state of the data consistent. Yes. So that was the users. Now again, more to the internals of the implementation that can become a problem, or that can be relevant for the performance. So I didn't mention any logs, but there are a few of them. There is, for the updaters, there is the per CPU spin log, which basically logs their CPU replica, but the log is taken during the flushing as well for the CPU replica that we are flushing currently. Then there is also a bigger log, the Cgroup airstat log, that's taken during the whole flush operation when we manipulate the update tree globally. and it depends on the context of the flusher. Actually, for example, the user space, the flush is initiated from the user space. They can even put some contour riskettes into the flushing so that it, yeah, because it means it indicates that flushing is expected to take longer sometimes. And then there is a specialized log that's used only for the memcg flushing, because memcg adds some overlay on this framework. We'll get to that later. Yeah, then the problem for the scalability, it's also the callbacks of the individual controllers, because depends how much data they have. So it can slow down the flushing as well. And yeah, the time counting that's there from the beginning, and the BPF callbacks. So that's freshly. I think it's just in BPF next 3 now, but it gives like opportunity to run the BPF code inside the flusher, so we can see surprises there, I think. The global accesses, it is just for completeness. I think that they are not so important at this level now. So I said that memcg has some customization or no customization. It adds some extra optimizations above the flushing, because here for the illustration there are several types of the entries that it tracks, and you see that there is, depends on the configuration of the kernel, but there is around more than 100 of them. Those are arrays that have to be processed, that takes time. So what memcg utilizes some kind of lazy flushing. So when the read request comes, we don't flush it necessarily, but we have some estimate of the error, and if we estimate the error is too big, above a threshold, we initiate the flush. So that comes yeah, that comes with the the results that we get come with the possible error, and currently here I have 2 formulas because it depends. The error can be proportional to the number of CPUs times some constant, which we just consider it a constant, or it depends on the asynchronous flushing period times the activity of the writers. CR stands here for the change rate, and it's not easy. It's not easy to combine these 2 into 1, so I put that as the 2 formulas. The historical note is that memory management code needed the data collected even before the RStat, so it had its own implementation, which was also affected by the error. The error was even bigger because it was proportional to the size of the subtree, and was causing the problems, and there were also Cgroups in the subtree. But the upside was that it was actually quicker because there was no flushing involved, explicit flushing. So now I will get to the part where I had my theory about how this lazy flushing can be a problem. Here are 2 plots. An important note that this is not based on real data. This is just basically a picture, hand-drawn picture to illustrate my theory. At the top, we have some diagram of the flush work that it's being done when a reader initiates it. With the blue crosses, the blue crosses represent the eager flushing, which actually happens. That would mean flushing every time, and it's like the full amount of work. If we use the lazy flushes, you see that they are mostly just checking the error, and only from time to time, when the error accumulates, there is the full flush work. That's visible at the bottom, where we have the error estimate. So yeah, the blue line, the error estimate grows, and then it drops after the flush, and the red line shows that the error is always very low.
No, as I said, this is not real data. This is just I used plotting software to draw a picture. Now, then when I was thinking about this, I thought that as we have more and more counters that are tracked for the MMCG, we run into a problem with the amount of the flushing work. Initially, the details are here in the linked email, but I will not go into the details. But the idea was that the full flush work is proportional. It's proportional to the number of items that we are flushing in the callback. And here's a mistake in the slides. Actually, the time to reach error estimate here should be the frequency. Frequency of reaching the error estimate is also proportional to the number of items. Here, what I mean is that the more, because the error estimate is global, each item contributes to the error estimate. So if we add a new counter, it means that the error estimate grows bigger if the counter is active. So we faster reach the threshold error. And if we put these two together, so that would mean that adding new items would mean that the amortized or average flush work would scale quadratically. So that looked like a bad outlook to me. So I wondered whether it really happens. So I prepared a measuring setup where instead of inventing new counters, because like I had no use for, or I would have to invent also the events that they would be counted. So instead I used inverse approach where I was reducing the number of existing counters. Big notice here that this was an intrusive experiment, as I was hiding the counters, so I was affecting the behavior. But basically, I used the mask variable, and I removed the counters from the updates path and also from the flush path, so as if they were not existing. And what was also and I run this experiment on the multi-CPU machine, of course, to see some differences. And the workload I had was a compilation of a Linux kernel, and in order to stress the reclaim path so that there is actually someone asking for the statistics and acting based on them, I applied a memory limit. The memory limit was configured so that it's slightly less than the free running compilation requires, so that there is actually some need for the reclaim. Now, what I saw with this, I saw basically the violet crosses, and you can see that they are mostly random. On the x-axis is the number of available counters, and on the y-axis is the average flush time. So my expectation was the dashed line that I could see some increase in the flush time, but actually if I tried to do a real fit, so it even went slightly down. But I think that this is not relevant because I think the data are quite noisy. So I could not, with this workload and with this setup experimental setup, I could not see the expectation of the quadratic dependency. So that's a good on one hand, but also it made me wonder what is wrong with the theory. Here is a histogram of durations of the flushes. So on the violet part, we can see that it's bimodal. The lower peak are the quick flushes when we just check the error, and the second peak is
is the full flush that takes longer, but there is less of them. For the comparison, there is data from just a single counter enabled. And we can see that there are still some of the quick checks, but instead of the second peak got even longer. The expectation was that, yeah, the expectation was that it should get actually shorter, but so I will get I will try to explain it later. But on average, I think the time of the average flush didn't change, or it's within the very error. Here is a third projection or third look at the experiment, where here again I compare the variant with the lots of counters, the variant with less counters, and there's the error estimate that's tracked in the memcg code. So what caught my eye here is that this error estimate is counted in an atomic variable across all CPUs, and recently there was a patch that changed the way how we increment this variable. That originally we would just increment the variable every time, and if it's above the threshold, we initiate the flush. But someone have a quite good idea that we don't have to update this atomic variable if it's already above the threshold. So it avoids one more write to the atomic variable. And I mentioned that this happened on the CPU with 48 CPUs. So it's surprising to me, or at first it surprised me that at the top picture we can see that the value is quite often above 48 CPUs. So it means that the individual updates are so big that they, even if with a single update, we pass the threshold, and the new condition does not come into play. Yes, so those are some results I got. I still don't have a good conclusion why I didn't see the quadratic behavior. I would need to perhaps add some more views into the system. So that was about the experiments. Now we get back to some real stuff. Or
we're running out of time. It's supposed to be next speaker right now.
Next speaker. Okay, so I'm running out of time. So okay, there were some optimizations, some anti-optimizations, I would call them. And okay, so here is possible list of topics for discussion if there is time for questions, or we can get in touch elsewhere.
Yeah, like this, there should be time for doing lunch afterwards, or people can use the matrix room to ask any more questions there.
Okay.
Thank you very much.
Thank you.
It's local.
The next one's going to be on unprivileged true.
Yes, hello everybody. My name is Eunice Manton, and today I'm going to be talking to you about unprivileged CRU. That is to say, being able to run CRU without requiring root privileges. A little bit about myself: I work on OpenJ9, which is an open source JVM. And recently, you may have noticed that JVM folks have been very interested in CRU. We've been lurking on your mailing lists and in your channels. And if we have some time, I'll talk a little bit about why that is, the problems that we have, and how we think that CRU can help us. So the talk is divided into two sections. I'll start off by talking about the problem at hand, which is running CRU without requiring root, the current state of the work, and where we are in the development process. And then later on, given some time, I'll talk about our specific JVM startup issues and the motivations and challenges that we have. So just fair warning, I don't consider myself to be a Linux expert by any stretch of the imagination. I don't even consider myself to be extremely knowledgeable. I think I know enough to be useful, and I'm certainly open to comments, suggestions, and constructive criticism, so please don't be shy. So let's talk about CRIU. Essentially, this work involves allowing CRIU to dump and restore a subset of programs without requiring root. Essentially, this is done with using the capabilities subsystem, primarily using cap checkpoint restore, which was added recently, not so recently now, to the kernel to kind of plug the gaps of what was missing to allow CRIU to do this. And the idea is, simple idea is that you set this cap on your executable, run with -- unprivileged, and hopefully you can dump and restore some, but not all programs. Some things simply can't be done without root in the current state of affairs. So my approach has been to first try it as root. If it doesn't work as root, it's probably not going to work in unprivileged. If it works as root, then you can go on and try to figure out if it works without root, if you can get it to work, if you have to modify things. But that's been my general approach to this problem. So the original patch set was opened in mid-2020. That's about 2 years now. The original work was done by Adrian Reber and Nicholas Vieno. I don't know if they're in the room today. Wonderful. Yeah, good to meet you. So the original work was done by Adrian and Nicholas, and as I said, it needs cap checkpoint restore. The current set of patches can work with cap sysadmin as a substitute. One of the questions is maybe we don't need that right now. Certainly 2 years ago when the work started, cap checkpoint restore wasn't everywhere where we needed it to be, and using cap sysadmin was a way to kind of get this testing going. But maybe it's time to revisit whether that's a good idea or not. And one of the things I didn't appreciate about this when I first started looking at this is that cap checkpoint restore in and of itself isn't enough to do everything that CRIU needs. It really just provides access to the things that weren't already provided by other caps. So you kind of need a constellation of caps, and it depends on your program and the internals of what your program does and what needs to be saved and restored. Certainly that didn't occur to me when I first started. I just figured cap checkpoint restore, give yourself that, and you're good to go. But the reality is that you try with cap checkpoint restore, you fail, you look at the log, you see why it failed and what other caps you need to have to be able to dump and restore your specific program. So some of the other caps that you may need are listed here. sysptrace is fairly important. netadmin, also fairly important. The other ones I've been able to get away without needing, but may vary on a case-by-case basis. So the current patch set was opened about a couple of months ago, actually, by myself, and essentially, I'm going to admit I didn't really do too much heavy lifting. The credit goes to Adrian. I simply just rebased the patches, fixed a few things here and there, and more or less continued what Adrian started. The only significant thing I've added here is RPC and libcru support for unprivileged. primarily because that's what we use. So we kind of needed that part and made some changes to the way the current DAT works. I probably don't need to refresh anybody's memory in the room about what this is, but for anybody else who might be listening to this and new to CRIU, to some of my JVM colleagues, the current DAT is basically a cache file that represents everything that CRIU knows about the currently running kernel. Essentially, you need that to be up to date with the currently running kernel. And if there's a reboot, potentially the kernel changes and you have to figure out whether your cache file is stale or not. The cache file is kept on /run, and that has the convenient feature that it's a tempfs file system, and it goes away when the machine gets rebooted. So we don't really have to worry about whether the current DAT is stale or not. It goes away and we rebuild. In the original patch set that Adrian worked on, the user does not have right access to /run, so there needed to be an alternative. In the original patch set, the current DAT was stored in the home directory, persistent, and then you kind of have to worry about whether or not it matches the currently running kernel. So Adrian suggested that maybe xgd runtime directory, which is also a tempfs, would be a good alternative, and that maintains the behavior with root CRIU that the file just goes away, and we don't have problems like that anymore. So all I did was implement that. Really straightforward. So having said that, there are still a fair number of unresolved questions. I've gone through the pull requests and read all the comments to try to figure out what thoughts people put forward that may not have been answered, any kind of there's unresolved questions and things that were brought up that maybe deserve an answer. Some of these may not be relevant anymore. But the reason I bring them up here is I'm hoping that by bringing them up, it may jog people's memories, and if they have some fresh insights into these questions, I'd certainly appreciate hearing them, or if they're not relevant anymore, discuss that as well. I don't think I'm going to go through all of them. A couple of them, or maybe in passing. The first one, what do we do with a cheer-rooted process currently? If we don't have the capabilities to restore the true root, we simply pretend that we did and go on. That may or may not lead to failures. Is that the right behavior? No. Answer to that. Second, what do we want the default non-root behavior to be? If you invoke CRIU as non-root, do we want to just assume that you want unprivileged? Do we want to be explicit and require you to pass -- unprivileged? I mean, kind of go either way. If this was a regular program, it probably would make sense to say, if you're running as non-root, maybe we should just default to non-root behavior, unprivileged behavior, and kind of skip all the things that we can't do or we know that we can't do. The problem with that is that you may successfully restore a program in a way that is kind of subtly broken. You got to the end of the restore process. The program is back. The process is running. You didn't restore some parts. Did you skip something important? Is the program actually in a safe state, or are there dragons lurking, or is your database going to be corrupted an hour or a day from now or something like that? So certainly that sort of behavior is something that we need to address. And the following points all kind of stem from that idea. Do we avoid doing things that we know are going to fail. We know that we're non-root. We know what capabilities we have. We know, the thing that we're doing, whether it's going to succeed or not. Do we avoid it? Do we just jump over it? Do we perform it and fail? Again, that goes back to we don't want to restore a process in a broken state, and I think it may be better to have the user know that upfront. Go right ahead. Yeah, if we have any questions, just jump right in.
We have the mic? Yeah, I wanted to say, sorry, is that actually, so I worked on the initial rootless stuff for Run C as well as for Umoji, which is like an image-based tool. And so in both cases, I had to deal with the exact same question about should this be automatic or not. I don't know if the same holds true for Creo. It depends on what the threat model is and how much you care about certain things. But basically for Run C, where we have the ability to say, we will fail if any aspect does not work effectively. So basically there is a config u, which is like a JSON file that is like basically the entire description of the container. And if we can do it, then we'll do it. And if we can't, we can't, is the way that we do it for Run C. Mochi, that's not possible because if you need to, for unpacking a container image, you need to like fake a bunch of stuff and so on and so on. And there's not really a way to like, basically no container image could be unpacked if you would fail at any point when nothing would work, right? And so for Umochi, you have to specify it. So I guess my view, I don't know if it's the same for career folks, but having done this, and it's very, very annoying because it's like, I want it to work and I don't want people to have to worry about it. But I guess it depends on the security model, but career folks are better than me.
Yeah, certainly a good point.
Yeah,
anyway,
that's definitely the hard question. I'm also unsure about it. I think it would make more sense if it actually fails. If you can't restore, then providing an half restored program. I don't know if that's really helpful in this case. Andre probably has.
With this unprivileged option, it was my idea to edit because my idea. Okay. So Creo is a low-level tool, and we want to be sure that users that use Creo understand what they are doing. I mean, we can understand that we are running like unprivileged, and we need to get some workaround for some specific cases, but actually we want to get approval from the users that we understand what's going on, that it will be not exact restore, but it will be unprivileged restore with some.
Yeah, that's a very good.
One more comment for me. I am very sorry that I slow on reviewing this stuff, so I will push myself harder to.
It's not a problem.
I think we are very close to merge this pull request and work. About root, this is one specific case that I don't like. I mean, the idea that we see right now, we try to do root. If it fail, we just exit and say, okay, this is unprivileged mode. We exit without any error. We don't notify the mode that root that we fail to do this. But actually, we call root for some reason. And if we exit without any error, if we don't handle this case in the code that means that we will probably fail in some other cases.
Yeah.
Or we will do something wrong and we will not know about this.
Exactly. Yeah.
So we need to find a way how to handle this part properly.
But do you mean if you have the unprivileged option, then it should just continue to work even if it's not able to restore everything? I'm not sure. So with the unprivileged option,
I don't want to say this. I mean, we need to handle each specific case and just try to find out what is acceptable for in each case. But we can't just say, okay, root doesn't work in unprivileged and just exit with 0 and say.
Yeah, right. Yeah, that's
And by the way, we have one more problem with Unprivileged. Doesn't work well inside user namespaces. Because we have a few places where we require global capabilities. For example, it's a page map. We read page map to do the memory dump. Find 0 pages, to find 4 pages, and all that. So we need to look at this part.
Certainly, certainly. So yeah, a lot of the remaining unresolved questions kind of center around what to do in these sorts of tricky situations.
We, remember a couple of years ago we talked about this. Do we want Creo to work from inside user namespaces? Like, I'm honestly asking. I'm not implying we shouldn't.
The short answer, we won't work from user namespaces because, for example, in this use case with Java, we want to support it inside containers, unprivileged containers, all kinds of containers.
Okay, you really want this to, we want to, okay.
Yeah, but I don't know how to handle this page map because there are some security issues.
I mean, hopefully, like some
Small
of those.
privileged daemon running on the host started by systemd at boot up.
Yeah, hopefully, some of those cases will be easier than others because like obviously running Creo inside a user namespace, which is then running something, say, Docker in it, gonna have a very bad day because you're gonna have also the mix then of potentially nested LSMs and all of that stuff combined with the fact that you're inside of a user namespace that also restricts what you can do and restore. And for something simpler, say like I mean, not calling a JVM to be particularly simple, but as far as process trees go, it is. That use case makes sense.
Is there any approach or idea, maybe even from the MM folks, with respect to page map and privileges?
I don't remember the details. We discussed this, I don't know, maybe 5 or 7 years ago. So we need to check this discussion and find out what was security, so how we can solve that.
Creo seems important enough that we can, have functionality in the kernel that is Creo specific. It's not a new thing, right?
Yeah, that's right. But someone to
do the work.
Make this.
Yeah.
I think we're about only halfway through your slides, so I guess that's it.
Yeah, I can quickly summarize. I think we segued into nicely into. I can quickly go through, which is our actual problems in Java and why we are trying to use Creo. And to summarize a long story very quickly, we want better startup. The JVM is for many, many reasons, very slow to start up. People who are writing microservices in cloud environments, they care about startup. And the philosophy in the microservices world is actually very similar to the Unix philosophy of having very small programs that do things well and kind of chaining them together, piping them together to do something large. And you can imagine if your greps and your seds and your awks took 100 times longer to start, people wouldn't tolerate that sort of thing. So that's kind of what's driving people to want faster JVM startup. They're writing small programs to try to manage large, complicated applications, but the JVM doesn't start up very quickly. Some of our traditional ways of gaining performance, JIT compilation, AOT compilation, can only help so much, and sometimes they conflict with fast startup. JIT compilers running right beside the application, taking resources. AOT compiler can't see everything, can't produce the same quality of code, and the Java language model makes that all difficult. So long story short, JVM slow to start up. And so we're trying to use CRIU to kind of to plug that gap, to start a JVM, save its state at a certain point and be able to restore it quickly. And the fundamental problem with that is that restoring a process is not like starting a new process, especially from the user's perspective, right? User expects certain things, and the unprivileged CRU addresses one of those things. People don't expect or want to run their JVMs as root. Program managers and sysadmins get very nervous if you tell them that you have to run their JVM stack as root. So that's kind of what brought me to this work. But other things are also at play here in that users expect when they start their program to be able to specify new environment variables, new command lines, and when you restore a program, obviously that doesn't work, and that they have consternation with that with that limitation. People who are using Cgroup to do process migration, they come from the mindset that they're aware that the process is being migrated. They know they probably can't change the kernel. They want to keep their user space consistent. People who are starting a new process don't think like that, right? Nobody really thinks like that. So using Cgroup as a sort of startup accelerator imposes limitations that the people are not used to. And we kind of have to massage that and change their expectations a little bit and maybe address them a little bit, and kind of there's a push and pull there. So I think that's kind of what is driving the challenges in this space. Hopefully, a little bit of understanding of why we're here. Certainly, using Cgroup is not the only way to solve this, but the reality is that most JVM code bases are monolithic, very large, and very difficult. It's very difficult to do a paradigm shift. Very difficult to take a JVM and do complete static ahead of time compilation. Simply difficult. It's a difficult thing to do, and Cgroup allows us to kind of accomplish some of our goals in a much easier way. So got some backup slides here that we don't have to go through about how we use Cgroup. You're welcome to look at them. I believe that brings me to my end of my time. Thank you very much.
I think, sorry.
Let's start by clapping first. Thank you.
Sorry.
Christian.
Yeah, I think for the pull request itself, it just needs to be just needs to be pushed over the finish line, right? So
yeah.
Hopefully the basics should be ready soon.
Thanks.
And now we've got Mathieu again, this time on restartable sequences.
Hello, so it's me again, Mathieu. Now the second topic I have for today is about restartable sequences. So I'll start with some good news, whereas with what I'm bringing, that's covered by the talk I gave on Monday. Containers get something for free, which is great. And then I want to discuss how I can do that over shared memory within containers. So bear with me. Just a quick explanation of what restartable sequence is and allows doing. So it's a system call that I pushed into the Linux kernel, commented to the Linux kernel. It registers a per thread area. So user space registers a per thread area, and that's glibc doing it since version 2.35. It allows user space to create small, let's say, transactions, which are managed by the kernel. And those transactions allow fast access to per CPU data in user space. glibc is making use of it to speed up its own sched get CPU because the per thread area can keep around the current CPU ID number. So rather than calling a VDSO, it's actually much cheaper to just do a load. So glibc does that. and on architectures like ARM64, where SCAD gets CPU, well, the get CPU VDSO was not implemented. I mean, that's so skipping a system call and doing a load instead is extremely interesting. There are use cases, major use cases for this. One of those is memory allocators. TC-malloc is a user of the restartable sequence. My user space tracer and counter tracking that's coming, also that last one within LTTNG. I want to make use of that. However, there are concerns about container and memory. So the problem statement. So in a large multi-core system, let's say you have a 256 core system that's partitioned as many containers using CPU sets. Having user space allocate per CPU data structures is extremely wasteful in terms of memory. I mean, if you take number of possible CPUs that the kernel knows about, and that's actually what the container is observing, that's going to be 256. And even if it's in a CPU set, that can only be running on, let's say, max of 4 cores. So the, of course, RSEC critical sections use per CPU data structures in user space. So we want per CPU data, but we also want to minimize memory allocation when there is little concurrency for threads touching the data structure. So ideally we want to allocate user space per CPU data with number of entries being a minimum between the number of concurrent threads that can touch that data, the SCAD affinity, and the CPU set. And it's also, of course, limited by the number of online CPUs. So more details, if you want more details about the RSEC per memory space virtual CPU ID, I recommend that you go and see my talk, the talk I gave on Monday in the referee track. But a quick problem summary. So this is really the per process part. So let's say you have a memory allocator. Your free lists, so your memory arenas are local to your process. So it's a private data structure. You would like to have that as per core free lists, but in a container, it can be extremely wasteful for memory, especially with CPU sets used. So, so for this case, I'm extending RSEC with a new field, vCPU ID, that's going to be exposed. That allows basically using, so we use the scheduler knowledge about the level of concurrency within a process to limit those values. So that's what it does in a nutshell. And I do this per memory space, so per process. And all is good, and it's going to improve container workloads whenever the memory allocator is using this feature to keep its memory arenas. So that's all great, all well. The one thing I want to bring up is about checkpoint restore here. So the notion of having well, extreme maximum of possible number of CPUs. Let's say you want to have an array of how many, what's the worst case, right? You can usually query the kernel about the number of possible configured CPUs. This should not go beyond that. That can be useful. I mean, if your user space code does not plan to extend beyond this initial size, that's useful. And then it could, let's say, well, keep null pointers for all that and do lazy allocation whenever there's actually use of those entries, of those indexes. But for CRIU, when you're checkpointing on a kernel and then you're restored on a different kernel, that number of maximum number of possible CPU might be completely different. So that's an open question to you guys. How do you think we should manage that? I mean, there are many ways to do this. Either we lie to user space, either we add some extra affinity limits constraint to make the system appear as having fewer CPUs than it has. I don't know. That's actually an open question.
I mean, it feels like one way you could treat that is effectively as another effectively property of the CPU. Kind of like you need to already match the CPU extensions and flags between systems because you don't want to restore on like an earlier generation of a CPU effectively. It feels like this might kind of fit in the same bucket, but like you don't want to restore on a target system that has less possible CPUs than the source one, maybe?
Well, having less will work. It's having more that's a problem.
Right, true, yeah, that way.
So
yeah,
it does not kind of evolve well. That's the thing.
Can we use Cgroups to limit the number of CPUs?
Yeah, I guess. I mean, you could artificially limit, I mean, with CPU sets. Cgroup CPU set could be a way. So you limit the restored process to a subset of the available cores. That could solve it.
Yeah, I think the main catch there is that you don't necessarily know whether the task you've checkpointed made use of that or not. So you effectively need to always capture at checkpoint time what things was like on that source system, so you can then decide what to do in the restore, because you can't tell whether a given task is actually actively using that or not.
Yeah. We can save the number of CPUs on the source host, and actually we already dump properties of CPU Cgroups, and this can help us.
What you want is to save your SCAD affinity mask, your CPU set that can be applied, and as well have some information about your maximum number of possible CPUs when you checkpoint. And then when you restore, so let's say your number of possible CPU extends beyond that, then you could, well, I mean, you use the other properties, and then you use the right masking to reduce that to what the old system could present to user space. So that could be done. Yeah. Thanks. Yeah. So moving on. So here's the problem I have. So it's all nice, this per process private data thing with virtual CPU IDs for memory allocators, but I'm doing a tracer. And that tracer makes extensive use of shared memory. So I want to be able to use that shared memory within a container without wasting too much memory, because currently I use max number of possible CPU and I allocate memory for all that. So it's extremely bad in a partitioned scenario because I'm wasting tons of memory. So in order to extend that, okay, so that's a summary about what happens in the root namespace. I mean, yeah, basically I use max the number of possible CPUs. I use get CPU to index through it, and that's pretty much it. But in a PID namespace or Cgroup CPU set, so the typical case is to use the CPU sets to restrict PID namespace to a subset of CPUs on the system. So as I understand it, you can specify a target number of CPUs, and then it can burst and kind of use CPU outside of that. And there's also a mode where you can really partition. So you delegate a partition of the mask of CPUs. So, and this is the domain CPU sets. There's also threaded CPU sets.
When you say burst, do you mean go above the set limit? Is that what you mean?
Sorry?
When you said target number with burst, you just said it can go above that. Do you mean it can go above, if you say CPU set equals 4 or whatever, 4 CPUs? Are you saying that you think it can go above 4 CPUs being used?
Yes, there are. I mean, if you don't use the partitioning mode of CPU set, if you just specify, oh yeah, go for 4, if the resources of the system are not used by other containers, you can get more than that.
I didn't know that.
We'll have to go double check. I mean, you guys are the expert. I
would say that's not possible, but I mean,
I know that's true for CPU shares. I didn't think it was true for CPU sets.
no, I would think no. I think that the way it works is that
Because it's restricting the scheduler as to what CPU ID it can schedule on. So that shouldn't be possible. It is true for shares. Like if you give an amount of effectively like a share of scheduling time, then those will be, that is under load, it will be applied. but not otherwise. But I believe that for the CPU set pinning, it does.
Actually, you can't even target number. I know LXD can because it does it automatically, but you can't target number with like the actual system with the actual API. You just set what CPUs you can use. You can't say give me any 4 CPUs, right?
Correct.
Yeah, so you can only partition with the kernel API.
Yeah, the kernel API gets you like a CPU set mask of like 0, 1, 2 to
Yeah,
4 or whatever.
Yeah, but like container runtimes hide this. Like
Yeah.
LXD will like you can say give me 4 and
Right.
it'll give you
So LXD, you can do the give me 4. LXD will then internally look at all of the other containers it has and figure out what the pinning is, and then write the specific pin into the.
but the actual kernel API is all partitioning.
Okay, I'll have to go back, read the
Okay, good,
documentation about this specific detail. Okay, let's continue that offline, but good point, thanks. Okay, so getting the maximum or mask for possible vCPUs for max size allocation is one of the problem we face, and having a getter for the maximum. Okay, so maximum number of possible vCPUs. Well, I could use the number of possible CPUs on the system, right? I just want to have an array of null pointers, basically, so I don't mind. But then getting a mask of online vCPUs for pre-allocation, so I could consider using the scale affinity or CPU set mask to actually have some idea of, okay, I need to pre-allocate real memory for all those entries, so that's fine. So the real, and that's really, I think it's my last slide. This is really the question part. So, okay. So this is really a restartable sequence vCPU ID allocation domain that would allow me to have shared memory used across processes within a container. But then where do I put that? I mean, I have a bitmap that the scheduler needs to keep track of to basically make sure that those virtual CPU IDs do not get used by 2 threads from that container at the same time, because then they would be touching concurrently the same per CPU data, and it's a no-go. I mean, that's a guarantee that I need to provide. So, but this bitmap, where do I put it? Should we put it in a PID namespace, user namespace, Cgroup CPU set, create a new namespace for that, and whether it needs to be hierarchical, which I don't think makes sense for this case. I think, I mean, having that hierarchical means you need to go up to the root, so you end up being kind of constrained in sharing with the root everything, which makes no real sense. So I think within a namespace, having the ability to have access to this notion of a shared vCPU ID allocation domain makes sense. But yeah, I just don't know where to put it.
My good feeling, and we'll see if Alexa agrees, is that it should probably belong to the same spot that's got the limit. Therefore, Cgroup CPU set would probably be the, because you don't like, you can totally apply CPU set rules to like a random set of processes that are not even part of the same PID namespace.
Yeah.
You can totally do that. I mean, the Cgroup CPU set only takes like echo a number of threads to it, the thread IDs to it, and they will be in that Cgroup.
Yeah, and this the CPU set Cgroup can be threaded, right?
Yes,
So
yeah, it's one of the threaded ones. Yeah, so you can even have, you could have a process like that has half of its threads in that Cgroup and half of the other threads in another Cgroup.
Yeah. The problem I see, so you're saying put that within the Cgroup CPU set,
Effectively,
right?
yeah, because
yeah, but the problem is, let's say I have a container which with a shared memory. I have tons of processes interacting on that shared memory. And let's say you have a few of those processes which gets into a sub CPU set, right? They get further limited. I mean, it would be okay for them to still interact in that shared memory. But if we make this bitmap of allocation in, if we put it in the CPU set, their current CPU set is now not the same anymore, and they cannot touch the shared memory anymore. It seems odd.
So the thing is, I'm not sure if putting a namespace would help you. I was gonna say that the namespace that immediately comes to mind is the IPC one, since the IPC one is for the system V IPC stuff. I mean, it's not. This is not IPC in that respect, but it was the first thing that came to mind.
Yeah.
So there is a namespace that does that, but
okay, yes.
I was thinking like, yeah, what do we do for shared memory? It's like, well, the IPC namespace would be kind of the go-to for that.
Yeah, but the thing is,
But it would still be a relation of the two. It's like IPC combined with CPU sets in some way.
Well, in some way, what I want to do is IPC over shared memory, right? If we just take by definition, right?
Yeah.
So I mean, requiring people to, well, I mean, in terms of documentation, okay, if you want your processes to do IPC over a shared memory file, please make sure that they are in the same IPC namespace.
Yeah, I mean that's already the case for System 5 stuff, right? You already need that anyway.
Yeah.
But I was gonna say that, I mean, yeah, the thing is that it's I guess the point is that in the case that you did not do this thing, where you now have this other process which has access to shared memory but now has a different CPU set or whatever else, and they can't touch it. That is like the fault of the program that did that, right? So effectively, if we can make a way for them to opt into this, that's actually what you want. It's not that you're worried about some security attack or something like that. It's purely that you want this process to be able to opt into saying, from scratch, I want to set up these RSEC things again, this shared memory.
Well, that would be kind of an attribute associated with the CPU set. Create a new CPU, a child CPU set that belongs to a different vCPU ID allocation domain.
Yeah.
So that could be opt-in, as we say. But I don't know. I kind of like the simplicity about documenting, oh, please share the IPC namespace. And
Right.
That's it.
I mean, for containers, we already do that.
Yeah.
Okay, thank you. Okay. IPC then.
Yeah. IPC isn't hierarchical though, right?
No.
It is not.
It's
No,
not.
it's
a-
one of
No,
the
but it's
platforms.
okay. I don't want it to be hierarchical.
Okay.
Yeah.
Yeah.
Because I mean, thinking about it a little bit, it does not really make sense to, I mean, you want to have one ID that you will use to index something in an array, right? If it's hierarchical, what does it mean to have the parent of the parent of the parent being able to use that shared memory? It means that the root namespace needs to share that exact same bitmap. And then you're back to not being able to take advantage of any of what this brings. So, yeah.
Okay. I mean, whether you get how you'll tie together IPC and Cgroup, that'll be a different topic. But I mean, I would say that in theory, that to me that would make the most sense, depending on obviously how it actually shakes out when you go implement it.
It's going to be kind of funny because like the actual limit, which is on the CPU set side, is hierarchical-ish. I mean, it's one of the CPU set thing is absolutely
ish.
terrible for this mess, but
Not ish. It's kind of that's the whole point of Cgroup v2, right? It's strictly hierarchical.
yeah.
Yeah.
Yeah, I just remember the nightmare of like the I think Cgroup 2 still has the issue. Cgroup 1 was particularly bad. Where like if you've got a child process that's like in a particular CPU set, and you go and change the CPU set of the parent, then all hell breaks loose because
You
that
can't
can't propagate and doesn't know what to do with the child CPU sets, and it just
I
gets
don't-
really wonky.
I don't think that happens in Cgroup 2 though.
I don't remember what it does in Cgroup 2. I
So
know
in
it
Cgroup-
just fails in Cgroup 1. Like in Cgroup 1, if you try to modify
It
the
doesn't
parent, it
propagate
just fails.
changes down if there are any active users of a given CPU. So if you want to remove a CPU, but in any child C group there is still a CPU set that contains that CPU, then you can't. And if you add a CPU, I don't know if it even propagates. It might propagate, but CPU
yeah.
set 2 in C group 2 CPU set has solved it, as far as I know.
Yeah, because I remember like writing some logic for Alexei that we didn't actually implement. But I wrote the logic for it. Which was like, if we want to do this safely in Cgroup 1, we need to like freeze the container, go in all the child C groups, allow them to do both their current stuff and the new stuff we want. Then go in the parent and restrict parent, like remove there. Effectively, no, we need to bump the parents to allow both existing and new, propagate that through, and then shrink things back the way back down. Like,
The nice thing about this mechanism that I'm presenting is that it's completely independent of the technology that applies the constraints. So you can use sched set affinity, and it's the scheduler that observes how much concurrency there is for the group, and it allocates the bits. That's it.
I wanted to ask about adding. What happens if, because you can add to a running process, you can add it. You can give it a new CPU it can run on during runtime. I mean, if it's in a leaf, right? Obviously, but because you were saying earlier that you have the check or restore issue, where if you restore onto a thing, there's a different number of total CPUs. The same thing would apply on like a running process where you can add a CPU, right?
Can you repeat that?
Sorry, so because like in a C group, if you're running a process in a C group and it's already set up, you can just add a new CPU to its CPU set, effectively, and the process does not know by itself. I mean, I guess there probably is a thing it could poll to get that information, but most processes would not know that that has changed.
Yep. So the thing is, you pre-allocate the max configured CPU for the whole system, right?
Okay.
That's the null pointers, and then you need to lazy allocate on first use.
All right, this is the lazy allocation thing. Yeah, sorry. So, yeah, okay, right. Yeah, so it's not a problem. Yeah, okay.
I think that's a good question. Sorry, this is a side, but is Cgroup.cpu set pollable?
I mean, Cgroup it does have polling stuff like built in, and a lot of it's pollable.
Cgroup stat and all that kind of stuff.
I
That
don't
would
know.
be or populated. I think you can poll. It would be interesting if you could poll the CPU.
I can take a look later, but yeah, that's a different topic. Sorry. Yeah.
All right, that's all I have actually. So if you want to have an early lunch, we have 2 minutes.
Well, no, we still have one more talk because lunch is at 1/2 past. So yeah, we've got.
Oh,
one
there's
more.
another talk, right?
We've got one more remote talk and then it's lunch. Yep.
Perfect. Okay, thank you.
Thank you. All right. So did you give him presenter? So he just needs to switch the slide. Oh no, we still have
No,
presenter here. Okay.
Alex should take presenter and
Yeah,
then
he's got it.
Okay, good.
Then switch slides. Yeah. If you want to switch the slides, click on the plus sign, and you should be able to select slide deck.
Hello guys, can you hear me?
We can hear you. Yeah.
Great. All fine with my microphone? Or maybe I am too noisy? It's okay? Sound level is okay?
You just have to switch your slides. You click the plus button and then you just pick your slides from the list.
Yeah.
We can see your slides.
Okay. Awesome.
That's what this. I think that's what James just did.
1 second.
I don't, so I guess he took it back.
Oh, sorry. I thought he took it.
Yes.
There we go.
Perfect.
All right.
Okay, sound is okay? Sound level.
Yep.
Great. Hello guys, my name is Alex Michalitsyn. I am software engineer at Virtuoso, working mostly on the kernel, containers, and CREO project. And today I want to bring the topic of the problems of checkpoint restoring the fuse mounts, because we have this problem for years, and we haven't supporting this because it's too complex, and we have a lot of issues here. And this year, my former colleague Vitaly Strosablin and I started to approach this problem and tried to make some design for this and proof of concept for some parts of the implementation. And okay, let's start from the discussing about the ways of handling the file systems in CREO. CREO handles file system using special structure called FS type in the CREO code, and this structure contains a few useful callbacks such as dump, restore, and pairs, which is called after the mount info parsing to do some extra work if it's needed for particular file system. And also we have some special callbacks like can mount or isbe equal. And let's consider some examples here. For example, we can take the TMPFS, one of the maybe easiest file system to support. In this case, we just need to save the entire file system tree to the image on the dump stage, and then on the restore, we just preparing the mount and then unpacking the archive to this mount tree, and then we restoring the file descriptors and so on. Another thing is the block device-based file system. We don't handle this file system any special way on the Creo level because this file system mostly provided as an external mount because this file system can be mounted in most cases only as a root user because some evil person may craft special loop device with special file image under this device which can crash the kernel if you try to mount, for example, ext4 over this image because we have no any any guarantees about security in this case. That's why we have this restriction. One of the most important example is the overlay FS. I'm sorry?
There was nothing.
Okay. Yeah, if you have any question, just break me. Okay. And another important example for us is the overlay FS, of course, because it's used by Docker and other container runtimes. And for this particular case, we had to add special callback called canmount, which is only in OpenVZ fork at the time, but I have plans to provide some new patch series to overlay FS kernel, which allows to extract some data needed for the dump procedure. But in OpenVZ kernel, we have these patches and we have it working. And this callback used to detect if all dependencies is resolved before we can mount the overlay FS, because overlay FS, as far as you know, uses some other parts of file system tree. So we need to be sure that all desired mounts already mounted at the time when we want to create overlay FS mount. And a quite weird example, and I think that most complex example is the NFS. It also supported only an OpenVZ fork, but it's of course open source thing. And this was supported for a few years. This work was originally developed by Stas Kinsbursky, our former developer. And here we have very tricky way to support this. We can't mount NFS, we can't restore NFS mount directly because we have no network at this point of time. And also we have network locking scheme in the Creo because of the sockets restoration procedure. So we can just mount NFS directly, and that's the problem. And what we can do here, we just mounting some replacement file system which is called SPFS.
Alex, we lost you for a little while here because there was some issue with the room. What was the last thing we actually heard?
We can't mount NFS.
Okay.
Yes.
Can you start the slide again? Sorry.
Okay, yeah, it's okay. Yeah, we can't mount NFS because we have no network at this point of time, and also in Creo we have network locking because it's needed to the TCP sockets restoration. So there is a lot of problems with that, and the solution here was really interesting. We mounting specially crafted file system, which is fuse-based file system called SPFS, stands for Stub Proxy File System. And this file system is just, as far as I mentioned, is a fuse-based file system, and the user space daemon of this thing controlled by using sockets. And we can send the command to this daemon and switch between the modes. And we have two modes here. One called the stop mode, which is the stupid mode when each EO which is requested to this file system will hang on the futex inside the user space and on the kernel in the stack which is waiting for the fuse response for the user space. And I will later inform you why it's needed. And another mode is the proxy. Proxy mode is the simple thing. It just translates all the file requests, all the requests to this file system to some another directory. It's like a proxy file system, just transparently allows you to transparently call anything to another directory. And first of all, in Creo, we set the proxy mode and mount this file system instead of NFS on the place of NFS, set the proxy mode and performing opening files. And this is why it's important. We opening files not general way, but like a ghost files. We just recreate all the files from the scratch, but without the contents. We only preserving the paths and metadata for the files like flags for file descriptor, for example. And then we, after the file restoration procedure, we're setting the stop mode for this file system because we don't need anymore to access this file system during the Creo restoration. And then after Creo restore finished and Creo finished execution, a special program called SPFS Manager started and freezes the process tree and traverses the process tree and lazy unmount the NFS mount, replaces it with the NFS mount, and then traverse all the processes using the parasite and replaces file descriptors from the SPFS to NFS file descriptors. And you may ask me why you need this strange stop mode for that. And that's the answer, because when you releasing the processes after Creo finished, some of process may access some NFS file descriptors. And because of that, as we not restored NFS at this point of time, we need to make the process freeze on this IO and waiting for the replacement to the NFS file system. That's why we have this special mode. And of course, it's quite obvious that when we freezing the process tree and replace the file descriptors, in this case, the processes gets interrupted by signal, and this system calls like read, like write will be restarted. And after we releasing the processes at the end of the whole process, the process will get the desired data from the NFS file system from the kernel. So it's like a quite complex thing, but this is a good motivation for talk about the fuse. Okay, let's talk a little bit about the place of mounts restoration procedures in the whole restore scheme here. First of all, Creo restores the mounts and then tasks and mappings, because we need to restore file mappings too, and we have this order of restoration. What's the problem with Fuse? Fuse is some way close to the NFS because some Fuse daemons may also include the network usage, and but there is many more problems with the Fuse because Fuse daemon is the part of the container process tree, and Fuse daemon is just a regular process, and this process may share some memory mappings with other processes. It may use the Unix sockets or network IP sockets or anything, signals and things like that. And we just can't restore the Fuse mount because we need the daemon for it. As far as I mentioned earlier, we have the order, mounts first and then tasks. So, but for mounting Fuse, we already need a task, and that's the recursion. And how to break this loop? The way to achieve that is to try to make something like the fake daemon. So yeah, we have we can spawn a fake daemon, and then we need to replace this fake daemon to the original one. But how to do that? Consider the Fuse mounting procedure from the user space perspective. If you take a look on the Fuse lib or any Fuse file system, you will see something like this. The opening of the Fuse file descriptor to this device, and then building mount options string for the Fuse device with the FD parameter, which is set to the number of file descriptor in the process who opens this file descriptor, the step 1, and then mounting, and inside the kernel, interesting things occurred. This file descriptor, which is basically just and empty at the first step, will filled, and the private data pointer will filled with some meta information for the kernel, and this fuse device file descriptor will be assigned to a particular fuse connection and will be assigned to particular mount. And yeah, I have written on the slide the names of the functions from the kernel where these interesting things occurred. And then kernel sends the fuse init request to the user space, and the user space should answer to this request. And after that initialization is happened, and user space may use read or write syscalls on this file descriptor and to interact with the kernel and to implement the file system syscalls. Yeah. What about daemon replacement? We can just spawn a fake daemon process at the first step and open the fuse, perform the mounting, and then we can, as far as I mentioned earlier, on the step 3, after step 3, we are getting the almost ready to use file descriptor, which connected with the fuse mount. And this file descriptor can be stored some way in the GRIO, and we have a great subsystem, small subsystem called FD store. This is like it's just a Unix socket with the with a pair of Unix socket which is connected to themselves, and then we can use it to push the file descriptor to it, and then once we need to use some file descriptor, we can receive this file descriptor from this storage and use it to something else. And we can utilize this subsystem to store this valuable resource for us. And once the real fuse daemon task will be restored, we can use the fdstore storage to receive this file descriptor and to push it to the real fuse daemon process with reopen, and then this process will continue waiting on the requests and process these requests. That's the idea of this thing. And we played with that, and it really works. That's good news for us. But that's not all, because we have a lot of other issues. The second problem is the opening files. As far as I already said, we have the special order frustration like mounts, tasks, and file descriptors. And during the opening files, we will accept the fuse mount. But if we have this fake daemon, it can answer to the with appropriate answers to the request from the kernel. And we need somehow to modify this fake daemon to achieve the desired files in open state. And let's talk a little bit about the way. Yeah, we have the special structures in CRIO, which describes the file descriptor dump and restore procedures. In this case, we talking about the file desk ops structure, which contains the open callback. And okay, let's imagine that we learned how to answer to the fuse requests from the kernel, and our fake daemon just answers with some positive answer to any question from the kernel about this fuse file system, and allows opening any paths from this file system. But what's the problem? The problem is fuse inode ID. If you take a look at the kernel internals and the fuse internals, it's really very interesting place in the kernel. And you might see that there is special structure called struct fuse inode, and this structure contains the field called node ID. This node ID is just like an inode ID for other file systems, and the difference here is that this ID is used by the user space daemon to distinguish files So when you take in a read or write or any IO or a map on the files from Fuse, this inode ID will be used by the kernel in the request to the user space, and user space should reply with also with the appropriate ID and use this ID to, as far as I mentioned, distinguish files. So as far as we understand, the user space daemon saves the information about these identifiers, and that's a part of the memory of the daemon process. And fortunately, after investigation of this question, I understood that we can control this identifier from the user space because user space provides it to the kernel from the Fuse lookup request response from the user space. And but the question is, we need at the dump step, we need to save this node ID for each files to distinguish the files from the Creo side, and inform our fake daemon about this inode identifier to make it work correctly with the desired passes. So we need to have a mapping between these inode IDs and passes at the Fuse file system. And yes, we can get this inode ID using, for example, file handles and using the syscall name to handle add, because the Fuse driver implements the Fuse encode FH callback, which at the binary structure of the file handle of the Fuse file, it will contain the Fuse inode ID as a field of this structure. What about the file mappings in Fuse? It's the quite interesting topic because fortunately a map syscall which doesn't lead to any Fuse request to the user space. That's good news for us. And just generic file map fold kernel callback is used on the VM area operation structure, and the Fuse file address space operation structure read page callback leads to just to simple Fuse read request to the user space, and after user space answers to this request, it just populates the page cache with the data. So it's good for us because anyway we need to have some way to answer these requests. But of course, we don't want to access the memory of these file mappings during the restoration process. So I believe that it's not a problem for us, because when we spawn the fake daemon and then replace it with the original one, and perform a map, we already restored the desired VMAs with desired flags in the kernel. We don't need to access this memory, so the read request will not occur, and that's okay. After we release the processes, if someone accesses this memory, the read page callback will be called in the kernel and all will work as needed. And unfortunately, I'm not familiar with modern things like ducks in the kernel, and this part of code I was not analyzed yet, but maybe in the future I will take a look on that. But I think that there is no many problems with that in comparison to the just generic mappings and things. What about dump? I'm talking about the restore procedure and problems, but I not mentioned the problems with the dump stage. And we have these problems because the Creo freezes all the process tree of the container, and Fuse daemon also get frozen, and the daemon can't answer to any request from the user space, but Creo uses stat_syscall to understand what the file is, to understand the flags and things like that, and that's a problem. We need my idea here is to create something like pre-dump stage. We already have the post for the memory purposes because we have the way to iterative migration, and predump is used to achieve that because predump allows you to dump the whole memory and then use iterative dirty tracking for memory to save the data, to save changes of the memory. But this is another predump stage for the files. And the main idea here is to make the statsys calls on the not frozen process tree from the externally, and then cache this data. And after all the process gets frozen, we need some way to check that the data which we cached before the process get frozen is actual at the point of the dump, because once the process tree wasn't freezed, some file descriptors may be closed or opened with the same number, and we need to check this. So maybe we need to KCMP syscall extension to get some cookie for the files, like unique identifiers in the user space or things like that, because KCMP syscall is great, and we are actively using it in the Cgroup to build special trees, like for file structure, to distinguish the processes, to distinguish file descriptors. But this syscall only allows to compare two resources at the point of time. But in this case, we need to save the cookie for the file, and then we need to get this cookie back at another moment of time, and then compare it. KCMP doesn't allow this, unfortunately. I think that there is some security problems with that, because but okay. And about status and plans, we have analyzed many problems, and we have the proof of concept for things, for example, like fuse daemon replacement. It's the out of Cgroup thing. It's just the construction with lib fuse with two processes. One of them replace another daemon, and the test which access this fuse file system. And we need to write some initial implementation for some super simple file fuse-based file system. And I almost sure that there are many problems which is not noticed by me and by me and Vitaly. And we will be happy if the community or someone wants to help or to brainstorm this thing, because it's quite interesting. And also, we need to support. We need to talk about the Fuse.ktl file system support, because it provides a lot of metadata about the Fuse mounts, and the user space processes in the container may open this Fuse.ktl file system, and this is also a problem. And I'm not analyzed it a lot this. And also we have fuse block device based mounts or CUs, but that's another topic. And another interesting question is the migration between different hosts with different kernel versions, because the Fuse protocol provides us with some ABI guarantees, and the in-kernel implementation of Fuse may have different versions, and user space should check during answering to the Fuse init request. User space may check this version and check that it's possible to answer to these new formats. And we also need to think how to provide the compatibility and guarantees here for the user, because if we using the fake daemon, we can answer with incorrect version. For example, the original daemon uses version like 6. This is just random number like 6. And for example, our Fuse fake daemon answers version 7, which is a kernel version, Fuse version, for example. In this case, we get a problem, because once we replace our daemon with a real one, we may meet some problems, because kernel doesn't know that the daemon was replaced. And possibly we may need to inform kernel somehow about this. I'm not sure. Oh, okay. Thank you guys for your attention. I'm happy to join this conference. Unfortunately, only virtual this year because of the Pavel and I failed to get our visas this year. And thanks for conference organizers, speakers, and attendees. Thank you, guys. I'm ready to answer questions.
Thank you. And yeah, looks like Andre's got something for you.
Thank you for this talk. I have a few questions. The first question, can we use SPFS to avoid all this fake daemon stuff?
Yeah, that's interesting question. But speaking honestly, the SPFS is the quite complex thing. The reason for that is, let me provide with some example. For example, in Creo we have support for restartable sequences, yeah. But because the SPFS manager does almost the same thing as a Creo, we also need to support restartable sequences in the SPFS manager. And from my point of view, that's the problem because we're duplicating a lot of code in SPFS manager like Creo does. We need to, and Creo is it's quite hard thing, and SPFS manager is also very has very complex code, not so complex as Creo, but also complex. And another argument here for SPFS, more maybe better answer is that why SPFS manager helps NFS? Because SPFS manager just replaces the NFS or the SPFS mount with the NFS. But if we're talking about the fuse daemon replacement, we need to provide we need somehow to freeze the fuse daemon after Creo finished, and not only replace the fuse mount with a new one, but we also need to provide the fuse device file descriptor to the fuse daemon inside the container. And I'm not sure that we can do it safely. Maybe there is some way, but that's really great point, but I need to think about this. Thanks.
Okay. The next thing, it's not a question, it's just the issue what I see right now. When we
Yes.
dump file mappings, we don't dump the memory in these file mappings because we expect that kernel will just save all data to the disk and we will get this data on destination from the file system snapshot. In case of fuse, we will freeze the container, so it means the kernel will not save dirty pages from these mappings, and we will need to handle this case somehow. I mean, we have a file mapping, and we just change a few pages, and then we this container. So these changes will be still in the memory. In the right
If we change, okay, we are talking about the fuse file mapping, and the user space, yeah, and the user space changing this memory.
Just touch some pages, just just write something in this memory, and then we freeze this process tree. So some data still in the memory. It was not saved on the fuse file system yet.
Okay, it's interesting, but because as far as I understand, we have a page fault on the page mkwrite with a page mkwrite callback, and these changes to the file mapping should be propagated to the fuse daemon in the user space. Maybe I am not correct.
It can be delayed. I mean, it's a write back.
Understand. So you're thinking about some way to flush the pending IOS to the fuse daemon before freezing, yeah?
I'm not sure that we were able to do this because in this case we will need to freeze everything except fuse daemon. Then
Yeah, that's also the problem because fuse daemon may connect it with another processes.
yeah, then call
Yes,
scene,
yeah.
wait when it will be completed, but
Yeah.
clear what part of which process just handles this fuse mount.
Yes.
Maybe it's just to save dirty pages, but I don't know how we will find them.
Yeah, thanks, Andrew. It's really great point. And yeah, that's why I have not analyzed the right scenario here and this thing with buffers. Thanks a lot for this point. I think we can discuss about this later. Yeah, thanks.
Because it's definitely a tricky one when you've got your file system running from within the same set of tasks that you're trying to dump. That's interesting.
Yeah.
But yeah, thank you very much for the talk. Thank you very much for the questions. We are now at lunch break time here. So also we wanted to say thank you everyone who presented, who came here, who attended, whether here or virtually, remotely, or on a recording. It was great to do this in person again. Hope we get to do it again next year. And thanks again for everyone who helped organizing this. Thank you.